at the start of May last year, I found it was a slight dimple on my left breast, basically. Hearing those words, your entire world just comes crashing down. You know, it's one of those things where you think, what did I do?
There are people who are like, skip the treatment that your doctor's giving you and just live healthy, live naturally. What do you want to say to those people?
I want to say that you're gambling, but the gamble might not pay off. And the thing is, you only hear from the people that the gamble pays off for.
Welcome back to the Checkup podcast. Today's guest is Dr. Becky Smethurst, an astrophysicist from Oxford University in the UK, who specializes in everyone's favorite astronomy topic, black holes. Believe me, we go into all of that, plus the inevitable death of the sun, who owns the moon, debating flat earthers, and of course, aliens. We also discuss Dr. Becky's startling breast cancer diagnosis as an otherwise healthy and fit woman in her 30s, and her experience navigating the UK's National Health Service. But she's not just an outer space expert. Dr. Becky is also an expert on YouTube, where she educates her audience of nearly 1 million subscribers about the wonders of the cosmos. As a working scientist and YouTuber, it turns out Dr. Becky and I actually have a lot in common. Please help me in welcoming Dr. Becky Smethurst to the Checkup podcast. Huge thanks to Garden Health for sponsoring this video. We function in the same space, but we don't function in the same space. And I use the term space purposefully. I get really excited talking about health science. You get excited talking about science, but on a different side of things. What side is that?
My side is astrophysics.
Okay.
So black holes specifically, because I'm obsessed with black holes, but mostly it's, the planets, stars, galaxies, alien life.
So like zodiac signs.
No.
Not the same.
Not the same, no.
When I watched the Dr. Oz show years ago, he said your zodiac sign can actually impact your health. Do you think that's not?
I don't think that's a thing. No, I don't think that inanimate, rocky objects that have been orbiting the sun for 4.5 billion years care about what we're all doing down here.
Fair. Okay, so different world.
Yeah.
How does one get drawn to astrophysics?
When I was a kid, I was the kid that was obsessed with space. Space and dolphins, to be fair. But, I was going to end up in one of those fields. I was going to be a marine biologist or an astrophysicist, which weirdly I think is like a common thing for a lot of millennials.
Because those are unexplored, deep ocean locations. Although dolphins don't necessarily live deep.
But the mystery of the oceans kind of thing. So I basically just never lost that spark of interest. Like, I was a why child. I constantly asked why all the time. And
did people get annoyed by that?
Yes.
What would teachers say to you? Because I'm curious if it matches with my experience.
The one thing that I remember from my school reports was Flibbity Gibbet was written on my report. From The Sound of Music, a Flibbity Gibbet, a Will the Wisp, the Clown. Okay. It's basically like she just bounces off the walls and just asks crazy questions all the time. She's just an annoying child. My mum says if she had my sister first, she would have had 4 more, but she had me first.
You taught her a lesson.
Yeah. So I just never lost it. And I think that's the hallmark of a scientist in research today is you have that innate curiosity to keep asking why. And so, when I was picking subjects to take at school or, what to do at university, it was, astronomy, astrophysics were always at the top of that list. And that was how I ended up just in a job that, now I'm researching black holes, which sounds crazy. I didn't go through school intending to do that. If you'd asked me what do you want to do when you grow up, I had no idea. But by choosing all the things that I love to do, it just sort of naturally fell out of that.
Yeah. What created that spark for you? How did you learn about the field in general existing or space existing? I mean, I don't even remember the first time I probably learned about space was through some Hollywood movie, Space Cowboys or something.
Yeah. I remember having a book that was just called Space, and it was just fact files about here's a fact file, a whole double page spread on each planet, and here's the stars, galaxies. And I remember devouring that as a kid. But I also remember thinking, oh, well, we know everything about space. And it was
we're done.
We're done. Yeah. Nothing interesting else here. We know everything. And so it wasn't until I was probably about 17 that I had chosen physics to study as one of my A-levels, as we call them in the UK, because it was one of my favorite subjects, not because I was thinking I'd go in a career to do that. But then I remember asking a question in one of the classes that the teacher didn't know the answer to. And was I don't actually think anybody knows the answer to that question. I don't remember what the question was that I asked. But I remember thinking,
Sure.
wait, there is something we don't know the answer to?
Yeah.
What? And then realizing that researcher was a job whose job it was to answer those questions that we don't know the answer to, right? And the fact that there were still questions that we didn't know that in terms of all of the side of astrophysics and space that I loved, it was just like my eyes were opened, and I was like, oh, I actually will go and do astrophysics at university now, and I will go study it, and that would be a really fun thing to do as a career.
Did you have any fear or hesitation because you didn't know ultimately what job you would get, but you were interested in the subject? Any thoughts there?
No, weirdly not. I think I spoke to a careers advisor at school, as you do at 17, and they were just like, you can do anything with physics. It's basically a problem solving degree. And I was like, oh, okay, cool. And I'd looked at lists of careers that people had gone into, and it was everything from finance and the banking.
Oh, really?
Yeah. Well, especially with things like insurance or anything like that. It's all mathematics based.
Actuaries,
So
right,
exactly,
yeah.
right. It's everything is like that. So you need someone with a really strong maths background at least, and they kind of don't care if you've done maths or physics at the end of the day.
Yeah.
Because it's just applied maths technically.
Yeah.
So it was one of those things where you just look at the list of careers and, teachers, yes, but also finance and banking. And then visual effects is one thing that I looked at as well. Because, if they're going to blow up a building, they need to know, in a film, not really, but if they,
to make
do
it
that.
look
Real.
legitimate.
Exactly. Yeah. So it was.
It's a shame they don't do that often with medical scenes in movies. With some medical dramas they do, but medical scenes, not so much.
Yeah. Fair.
Okay, so you're going into the field. You're really excited about the prospect of just learning, perhaps answering some questions that were unknowns at the time. Were you, because we touched on the subject, watching any movies related to space?
Oh, yes.
Yeah?
I remembered vividly watching Deep Impact and Armageddon when I was a kid. I loved those films so much. Elijah Wood in Deep Impact. I'm like, why is that such a nostalgic hug for me now? Probably to do with Lord of the Rings. But those films I remember, and especially the sort of the discovering the comet that's gonna, wipe out the planet
The
or whatever.
hero who's gonna save them.
Yeah, all of that. I remember thinking that was their job kind of thing. Also, I do remember in Top Gun, Kelly McGinnis's character is an astrophysicist.
Wow.
I don't know what she was doing in Top Gun.
Yeah, well, clearly you can go into any field. So.
Right. Because I don't know what she was going to do with whatever knowledge she got during her PhD on, I don't know, supernova or something to do with the Top Gun field. But
yeah, I didn't put that together actually.
No, I think it is kind of bandied around by Hollywood as just a word for a smart person.
Rocket scientist.
Yeah.
Yeah.
Rocket science.
And what is the difference between you and a rocket scientist?
Very different, actually. So a rocket scientist will be very much kind of the dynamics of how do you get something out of Earth's gravity, off the surface of the Earth into space. And then how do you bring it back down again as well? So it's the dynamics of the gravity of the Earth, but then the moon, if you're sending something to the moon, where is the moon? Where is the Earth? If we send it in this direction, is it going to end up there by the time the moon has moved into that spot on its orbit?
Okay.
It's all those moving parts. For me as an astrophysicist, there's kind of 2 different types or 3 different types of astrophysicist you can be. The first type is a theorist. So literally stood at a board with chalk being if we take these equations, that Einstein came up with about how we describe gravity, what does it then mean for what the inside of a star would be like? There's then people who run simulations who go, okay, well, if we plug all those equations into a computer, what do we get out? What does it tell us that the inside of the star is like? And then there's people like me, which is an observational astrophysicist, where you actually go and use telescopes, take the data, and then say, what does that data tell us about the universe? And it's a really interesting field of science because with most fields of science, if you have an experiment, you'll repeat it loads and loads and loads and loads of times to see if you get the same answer each time and see if it's repeatable. And, that's sort of the scientific method and process. With astrophysics, you observe a star and it can tell you one thing. So you have to then almost repeat your experiment by observing another star of the same type and things like that. So it's almost you're doing it population wide in a kind of similar way to medicine in that respect, I guess.
Yeah, it is similar because we can't run one of these randomized controlled trials for every condition. A, sometimes it's not feasible. B, sometimes it's not ethical. You don't want to force people to start a bad habit to see if it's going to make their life shorter. And at the flip side, you don't want to withhold a treatment for something that is already beneficial to their life. So the ethics can get quite messy when it comes to the healthcare side of things. But what our side is from the observational side of things is a cohort trial where I don't know what your version of that would be, where we watch a group of people over time and we see how certain things play out and see if any patterns can be elucidated, with the understanding that this is not the highest level of evidence. So I guess with you, it would be observing it over and over. And then is there a higher level where you can then say, now can we replicate it or attempt to replicate it? Or because it's happening so far away, there's no shot
that's the thing. Replication, not really a thing. I think with the cohort trial, as you called it, is basically what we do when we look back in terms of look back in time, as we say. As you say, every telescope is a time machine because light takes time to travel to us. So if we're seeing galaxies further away from us, so islands of stars, galaxies, like hundreds of billions of stars, then we're seeing them as they were when the universe was much younger. So we almost see how they evolved. You know, when you look back 13 billion years ago, it's like you're seeing baby galaxies. And now after like 13 billion years of evolution, we're seeing them as they were as like, you know, sort of, I don't know, whether they be middle-aged or old age, because we don't know how the universe is how long the universe is going to live, but we've seen them evolve in that respect. So that's kind of our sort of cohort trial. But then repeatability, I guess, is what we get from simulations. We say, can we reproduce what we've seen in observations by plugging all the laws of physics into a computer and seeing if the same thing pops out? And if it doesn't, we know we've missed something.
And interesting, you say we've missed something as opposed to creating a conclusion. Which is where I think a lot of misinformation on the health side starts coming out, where when researchers that are trying to be honest, they're trying to disprove their hypotheses and find reasons why their research is imperfect. Many people are just looking to confirm their research, and they have this ongoing confirmation bias. But that is exact opposite of what you'd be doing in your work, right?
Yeah, exactly. We're always trying to break physics. And I think that's where a lot of miscommunication comes from. Like you see headlines being like, oh, the Big Bang Theory is wrong. And I think most astrophysicists would go, yeah, probably. You know, there's probably something wrong with it. There's probably something we've missed and we've not considered. And, you know, we know there's a whole chunk of the universe that, you know, doesn't interact with light. You know, the dark universe, as it's called, whether that's dark matter or, you know, dark energy, as it's called. That's like 95% of the universe. And we're like, we still don't really know what that is. Of course, the Big Bang Theory is probably wrong, right? That's the point of a theory, right? It's always getting refined all the time as new evidence comes in. And as we make new observations of things that we haven't been able to before, thanks to new telescopes that can see further, you know, like more, you know, fainter things that we haven't been able to see, or even, you know, a new technique for observing something that, you know, we'd never been able to see before. That all changes things, you know. In the same way that, you know, people say, oh, the atom can't be split, or, you know, that kind of thing. It's like, well, you know, we'll never be able to observe a planet in orbit around another star because stars are too bright. Oh, well, actually, if we put something in front of the telescope to block the star's light, oh, actually, we can see the very, very faint planet. So it's like, just as progress goes, you know, there's so many things that end up cropping up that nobody expected.
Right. Do you remember the first moment you looked through a telescope?
Telescope? No, weirdly not. But look up at the sky and realize something different.
What did you realize?
So, do you know the constellation Orion? Most people know.
I've heard it.
Orion's belt. There's the 3 stars. So Orion it's not just his belt. He's a whole hunter, right? He's like a man in the sky with a bow and arrow, and he has like 2 shoulders and 2 feet. And one of his feet is bright blue, and one of his shoulders is like a red star, like a slightly orangey star. And you can see this with your eye. You can see the difference in color. Like it's very slight, but it's there. And I remember being like in a really, really dark sky when I was about 10 years old and looking up and sort of going, why is that star? Like, am I imagining that? You know, like as a 10-year-old being like, am I making things up almost? But my dad goes, no, you can see that. That's right. And we went and find out why it was. And it's because one of them is a giant blue star that's like the kind of hottest star you can get. And then
like most popular or?
No. Yeah, coolest. No.
Viral star.
Yeah, no, like the physically hottest star, the biggest star is like 100 times more massive than the sun. It's huge. It's called a blue giant star. The other one was called Rigel. It's the one that's in Orion's foot, and then the other star is Betelgeuse, which is a red giant star, which is red because it's at the end of its life and it's much cooler, but it's still a giant because what happens when stars start to run out of fuel is they try and like resist the fact that they're running out of fuel and they expand to like cool down so that like only sort of the bits in the center are sort of going to be
it's very human body-esque.
Weirdly, yeah. It's
like when we're cold, we try and redirect
Right?
blood flow to internal organs.
Yeah, so they're trying to like slow down the fusion inside so that they can keep fusing hydrogen into helium for longer by expanding to this red giant phase. It's what the sun will do when it eventually runs out of fuel and dies. It will swell to definitely beyond Earth's orbit. This is like 5 billion years time. There's like nothing to worry about. But like
you
definitely,
promise?
Yeah.
Okay.
Beyond Earth's
I'm
orbit.
going to hold it against you if it happens.
If it happens tomorrow, you can.
I'm going to leave you a nasty comment on Instagram.
Yeah, do it. But yeah, it'll be huge. So it's really cool to think of like the difference. And the funny thing is, every time I tell this to kids are like, hang on a minute, why is a red star cooler than a blue star? Why is a blue star hotter? Because if you think about like
It's color temperatures.
yeah, like even like, you know, when you turn on a tap, when you start a faucet, to use US lingo.
Well, we have
taps. When you turn a tap, right, the hot tap is red and the cold tap is blue. So like, shouldn't the blue giant star be colder and the red giant star be hotter? But it's like the opposite way around because it's talking about like light temperature. Like if you think about
like a light bulb.
yeah, even like the spectrum of light, right? A blue light is a much higher frequency, a higher energy, a higher temperature. So I like to say, like, think about the flame on like a Bunsen burner or like on a gas stove. That's a blue flame. So it's a really, really hot flame as opposed to like a dying embers of a fire, which is redder. It's cooler.
Yeah. Wow. And you were 10 years old when that happened.
Yeah, I didn't quite have that level of knowledge at that time, but I noticed it and thought, wow.
Something unique is happening there that you want to learn about. Now, you've probably looked into a telescope and observed stars and planets thousands of times?
Planets, definitely. Saturn is one of my favorite things to look through a telescope at, especially with people who've never seen it before.
Early on in your career, you're doing this. Are you feeling anything emotional, or is it very physics calculated? I'm looking at formulas and light patterns.
No, it's emotional. I remember the very first time I used a professional telescope. It was like the first year of my PhD, and it was in La Palma. So the Canary Islands, near like Tenerife, is one of the other islands up there. Very, very, very summit is like a big observatory where there's loads of telescopes that are used professionally. And we went to use one called the Isaac Newton telescope, and we were looking at galaxies with growing supermassive black holes, which we can get to. Basically, I remember you don't look through this telescope. Like, it's so big that there isn't an eyepiece because you're seeing, like, it's so big so you can see really faint things. So actually you wouldn't be able to see anything with your eye. You need the camera on the back of the telescope to basically open the shutter and just absorb light over like, minutes to hours, basically, to collect enough light to be able to actually get something on an image. And I remember like the first galaxy we looked at, it was a 20-minute exposure. And it was almost like really anticlimactic, sort of just being like typing a command into the computer, being like, go. And then being like, I guess I'll just wait 20 minutes.
20 minutes.
Yeah.
So what did everyone have for breakfast?
Yeah. But then it was like, what music are we going to play? I mean, my colleagues were like arguing over which musical we were going to put on.
That's an important question.
Yeah. But then after 20 minutes, my colleague Brooke, she was like, oh, the date is up. And I was like, oh, cool. And I looked at this screen and was like, I just couldn't quite believe it. Like this thing that had been this tiny fuzzy smudge on like the finder screen where it was like, okay, we know we have to be this much offset from this really bright star, and there's maybe something there, but we can see it. And then all of a sudden it was resolved into this amazing like spiral shaped thing. And I was just like, what? I think because it had been so anticlimactic when we typed in the command, to then have this thing just be realized in something that almost looked like a Hubble Space Telescope photo, which I think, I'd grown up seeing so many Hubble images that they'd become so iconic and so just like ingrained in your brain that this was something that, like incredibly, insanely clever people did at NASA and ESA and, and all of a sudden, we had a very pixelated, version of that because the telescope we were using, was looking through the atmosphere and Hubble isn't. So you get all like the blurring from the atmosphere. But I was just that like, we did that. Like we took that.
Wow.
And it was a really emotional moment for me because it was like the first like professional piece of observing I'd done as well. And even though I'd been a year in academia at that point doing my PhD and then obviously, all the time before, it was that moment that I felt like I was like, oh, I'm really like an astrophysicist.
This
now,
is serious now.
Yeah.
If you were to show that image to your friends and loved ones and show it with the level of excitement as you're describing it today, would they just go, what?
Yeah. Because first of all, it'd be black and white. And they'd be like, huh? Why is it black and white?
I think about it when parents, I mean, especially back in the day, maybe now the images are better, when they're showing an ultrasound of their baby and they go, look, and you're looking at static and you're like, oh, wow, that's beautiful baby.
Yeah. Where is the baby?
Yeah. So especially like a med student, you're training them to take a look and there's nothing to be seen really.
Yeah, no. I think the image they could probably appreciate. It'd be black and white because the telescopes really just record, is there light there? Is there not light there? So it's black and white. When they make the beautiful like Hubble Space Telescope images with all the color, what they're doing is they take an image through filters. So they've say, only let in the wavelengths of light that give us red colors, that give us green colors, that give us blue colors. And then you can add them together because you have an RGB image. And that's how you get something nice and colorful.
Wow.
So we just took a black and white image because we didn't need color. We just needed it through a single filter. And I think they could appreciate that. The bit they couldn't appreciate was what we also took, which is called a spectrum, which is where you split the light through like a prism, like into its rainbow of colors.
Okay. And
you record, okay, how much light of each color have you got? And you can make like a nice graph where it's like, oh, look at all these like sharp peaks and whatever. But the raw data almost looks like TV static. Like it's literally just like a strip like this.
Okay.
And it's like there's a brighter patch where there's a big spike from a certain color, which is from hydrogen that's giving off a very specific color of light. And basically you're looking for that really bright like stripe in the image that you know, oh, there's hydrogen kind of thing. And this, if I showed that to my family, they'd be like,
what are we looking at?
What even is that? Like, they'd just be like, this is nothing. And I'd be there like, look, but this is hydrogen around a black
Do you
hole.
get to a level where someone can pass you one and you go, oh, you got it? Like it's like, you know, when God, I'm making the worst analogies. Like someone gives you a rare Pokemon card. You're like, that's the Illustrator first edition.
Yeah, that's a shiny Mewtwo.
Yeah, exactly.
Yeah, no. I have that with, so the recently launched James Webb Space Telescope. I say recently. It was Christmas 2021. That feels recent.
That's recent.
It's recent for us.
Yeah.
In 13.8 billion years of the universe's lifetime, that's astrophysically recent.
Yeah.
But yeah, so the James Webb Space Telescope launched and it basically broke so many records of like the most distant thing ever seen. And the way they do it is you're basically looking for a really sharp drop off in light because essentially there's been a load of clouds of gas that have absorbed all of that light in the interim. So from the first time that absorption happened, you can pinpoint how far away it is. And so you're really looking for like brightness, 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 and then nothing. And so it's really fun when you see these like raw spectrum and people get it and it's like, look at that, look at what wavelength is that.
Is there a Guinness World Record for how far?
Yeah. Oh, what is, I think it's like 14.1, the redshift, I think, of the most.
I need a number.
I know, I'm trying
what
to
does
work out.
14.1 mean?
It means like a stretch factor. So it's like how much the light has been stretched by the expansion of the universe. And it translates, I think this is off the top of my head, but I think it translates to about 13.5 billion years.
Wow.
Like in time, in terms of that's how long the light's been traveling through the universe. So that's kind of like how far away it is, 13.5 billion light years. And then you translate that to be like, okay, well, the universe is 13.8 billion years old. So we're seeing that galaxy as it was when the universe was only 300 million years old, which seems like a massive number. But in terms of astrophysics, like that's really young. That's like, you know, just as the first sort of like galaxies and stars were forming.
This is pretty heady. You can lose yourself.
Oh, yeah.
Brainstorming in this scenario.
Yeah.
Does it stay, that feeling that you described in looking through this Canary Islands telescope? Or is it like, again, terrible analogy, so I'm going to apologize for all of these. When you move into an apartment with a nice view and you go, I love this view. And then 2 years into living there, you haven't looked at the view once. Is it like that?
I think you can get a bit complacent, especially with the numbers involved. Like you can get very like, oh, 1 billion, 10 million, whatever. It means nothing, you know, but it does. I think in terms of telescopes, I'm never tired of JWST images. Or there was a really cool tool on one of the, what's called the Very Large Telescope in Chile that like everybody in my field like drools over every time we see data from it. And like every time I'm in like a talk and someone shows up that data, I'm still like, yeah, that's really cool. And I wish I had that data, you know? So I think there is some aspect of that to some extent, but I still think, to be in academia and to be in like research, you have to love it. Otherwise, you just,
You'll burn out.
well, yeah. Or you'll just be like, I don't
You'll
care.
be like the
and
red
I'll,
star,
you know.
not the blue star.
Yeah, exactly.
So, wow, that's so interesting because my head, where I would be so curious, is to think about the human side of it all. Do you ever consider that the areas that you're looking are looking back at you?
Ooh, no, I've never even thought about that.
Oh, okay.
That's so cool though. Yeah. Like, I think about it so I don't work in the field of exoplanets, which is the search for planets around other stars in our galaxy, our Milky Way of like 100 billion stars. But there are people that do this, and like their express sort of like research field is finding planets. And it's cool how they do it. Like they can look for like planets passing in front of stars, and the star dips in brightness, and it does it like repeatedly. So you're like, oh, there's a planet there, which is really fun. And I feel like when I think about that side of things, I think, ooh, but could there be life on those planets? Like looking back at us and going, oh, hey, there's a planet around that star over there, and it's Jupiter that they've found, you know?
Yeah.
Like that's kind of cool.
So do you think there is life on other planets?
I think there kind of has to be somewhere.
There has to be.
Yeah, I think there has to be. Like, if you think about the fact that there are, 8 planets around the sun. The sun is
we lost one, right?
We lost one. I'm so sorry. Yeah. Pluto is a dwarf planet. He's the king of the dwarf planets, though.
Oh, that's kind of cool.
So I kind of feel like
does that mean something also? Like the
dwarf planet?
Star colors, does king mean something?
In star colors, no. I don't think there's a king of the stars. I guess.
Well, no. Is there a
stars,
king of the dwarf planets? Like, what makes him the king?
Well, he's the biggest. So he's the king of the dwarves. Is the joke? Yeah.
Got it. Okay.
So yeah.
And what's a dwarf planet?
Basically anything that's not. So there's 3 definitions for a planet. It has to be orbiting the sun. It has to be round and not like a potato shape. So,
Why? Why is that important?
So when things get big enough so that gravity essentially can take over to like shape things, it will naturally make a round shape. Because if you think about like,
and
if you had
gravity
a
is
cube,
important because hard to start life without gravity.
Yeah, I mean, planet definition doesn't really take into account life. You can have a planet without life. It's more so kind of things like, how do we classify what is a planet versus like an asteroid? Because asteroids are kind of like lumpy potatoes in shape, right? So why are they lumpy potatoes? Well, they're not big enough for gravity to have taken a hold to be like, oh, you know, it's weird that there's a skinnier bit here where there's less gravity between the surface and the center versus like it's a cigar shape and there's, you know, like a less of a pull into the center. So basically gravity will naturally round stuff over time. So that's like a second criteria. And the third criteria, which is the thing that killed Pluto, is that it has to have cleared its orbit. Like it has to be the like only thing in its orbit. Which for Pluto
feels pretty
actually
egotistical.
Well,
maybe Pluto's just really down to earth.
Maybe.
Literally.
But Pluto crosses Neptune's orbit. It actually gets closer to the sun than Neptune, like average distance from the sun occasionally. And also there's a lot of other stuff around Pluto. It's also technically a binary planet, Pluto. So it's like moon, which is called, I don't know how you pronounce it, Charon, Chiron, I'm not entirely sure. But I think there's many ways to pronounce it. Like Betelgeuse can be pronounced Betelgeuse. It's kind of like whatever you want.
Can it?
Yeah, it can. If you want to pronounce it that way, pronounce it that way. It's fine.
I mean, you can, but you'd be wrong. Okay.
No, I think it's totally fine. I think both are allowed. But Pluto is a binary planet because like Charon's not that much smaller than Pluto. So what happens is instead of like, because when something orbits another thing, it's not like the thing in the middle is static, right? The sun is not static as the planets orbit it. The planets pull on the sun slightly as well. So the same is true for the moon on Earth. It pulls on Earth. That's why we have like the tides. And so for Pluto and Charon is so, you know, not just like small compared to its planet in the way that the moon is to Earth. It's a very comparable size, which means that they orbit a position between them rather than something that's like in the center of Pluto. And so the two of them are sort of going round each other. So it's
how do we make that mistake initially when we did call it a planet?
I think because
people like me in the 7th grade were quite disappointed to lose a planet. I was
disappointed too.
It's like we're losing a piece of the solar system.
Yeah, I know. It was sad. I love how Mike Brown, who's like a astrophysicist, his handle is Pluto Killer because he was like one of the main people that like...
That should be his license plate on his car for sure.
I love that he's just took ownership of it. He's like, people are going to hate me for it. I might as well. I think the reason, it's just because, I mean, it was discovered in the 30s. Pluto. It was predicted that there was something out past the orbit of Neptune because Neptune's orbit was a bit weird. So people were actively looking for a planet anyway beyond Neptune. And then Pluto was found. And it was a really fun story how Pluto was found because we actually observed Pluto like 10 years before. Like there's what's called pre-discovery images where people had actually like taken observations with telescopes, and once Pluto's position and orbit were known, people were able to go back and go, oh, look, there it was in that image and we just missed it the whole time, you know, but it's because it was so tiny and so faint for telescopes back then. So when it was first found, it was actually thought to be a lot bigger because Pluto is not enough to pull on Neptune's orbit to make it weird in the way Neptune's orbit is. It's not really no planet orbit is circular, but at Neptune's orbit is very like elliptical compared to the others. And so it was like, okay, there must be something pulling on Neptune, something else big like Neptune. So we discovered Pluto and people were like, oh, it's the thing that we found. It's just a faint dot of light in images, right? So it's like, okay, from its brightness, you estimate a rough size, a rough mass, as we say. And people were like, oh, it must be the thing that's pulling on Neptune's orbit. So it must be this big. It must be as big as Neptune at least. And so it was overestimated already from the beginning. And then as more observations were taken of how bright it was, and I'm not entirely sure how they ended up getting it, like its actual size from brightness, I think, from other telescopes. They whittled it down. I'm like, oh, it's actually much smaller.
Poor Pluto.
Yeah, poor Pluto. Yeah.
It's always the mics that are killing the planets. I blame them all. So we got off the topic of life.
Oh, yeah.
Yeah, so people are looking at trying to discover new planets. Dumb question. Why can life only be on a planet versus on a star?
I mean, on a star, I guess it would just be the temperature. A star also doesn't really have a surface. It's a plasma as well that stars are made of. We talk about balls of gas when we talk about stars, but it's actually like the fourth state of matter, which is like ionized gas.
Ionized gas.
You've taken the electrons from their orbits around atoms and separated them from the centers of atoms. So the center of atoms and electrons are just roaming freely. We have plasma on Earth, like neon signs are plasma, essentially that glow that you get as a plasma. So it's a weird state of matter. So I feel like in terms of what we know about life, like a plasma of extremely hot matter is not the place that you will find it. However, never say never.
Yeah. Because that would be a cool discovery.
Yeah, it would, yeah.
Like a little amoeba-esque thing flying around the plasma.
That's like the plot of Project Hail Mary. So if you like that idea, read the book or watch the film.
There you go.
But yeah, so in terms of like, you could have life on a moon. So we're actively looking for life in places like
what makes a moon versus a planet? Because it kind of looks like a planet.
Yeah, so a moon is just orbiting a planet rather than orbiting a star. And you get fuzzy potato-y shaped moons, like Mars's moons, Deimos and Phobos, are basically captured asteroids that just look like lumpy potatoes. Whereas like Jupiter's moons, like some of them are bigger than like our moon, and almost the same size as Pluto. So, they kind of a fuzzy boundary, except it's just they're orbiting a planet.
Got it.
But we're actively looking for life in places like Enceladus, which is a moon of Saturn.
How do you do that?
So there's a couple of different ways. A lot of the time we're sending probes to those planets, to those moons. The Cassini probe, for example, that was in orbit around Saturn for a very long time and gave like those incredible images of Saturn. And also, the pale blue dot image, which I don't know if you've seen it, but it's a picture of Saturn looking back towards the sun and the Earth is just this tiny blue dot in the bottom corner. It, yeah. It's beautiful. But so Cassini was in orbit for a long time and it flew through these plumes of sort of like, almost like an ice volcano that's coming from Enceladus, like from in like this like crust. So there's an icy crust on the outside and we think there's liquid water underneath it because there's this sort of like plume coming out from Enceladus. And so they flew through the plumes and was like, oh yeah, there's water in there. That's really exciting for life as we know it, at least, because we know that all life pretty much needs water. And also looked for things like, organic molecules that make up life, like proteins and things like this that we need for life. And we can also do similar things with telescopes from the ground or from space as well. We can actually look at those kind of plumes if we can resolve them with our telescopes, and we can say, what is the light that's reflecting off those plumes, giving us in terms of like the fingerprint, like so if you have a molecule in something that's reflecting light, it can leave like a fingerprint on the light. So we know that it's there. So there's a couple of different ways you can do it in terms of like stuff in our own solar system. One of the missions I'm really excited for actually is a drone mission to Titan, which is one of the moons of Saturn, which will be really, really cool. Wow. It's literally going to it's called Dragonfly, and it's going to hop around Titan. And that's kind of looking for life as we don't know it.
Okay.
So life that instead of needing water might need ammonia or something to live instead, or methane.
Okay.
So that'd be fun. In terms of on exoplanets, so planets orbiting other stars.
Yeah. That's probably harder.
It's a lot harder. But it's one of the things that the James Webb Space Telescope got built for. And it's really cool what they can do. They basically wait for the planet to pass in front of the star, and then a tiny amount of starlight will pass through the atmosphere. And again, the molecules in the atmosphere will leave a fingerprint on the light. They will absorb a tiny little color of light away that then we can isolate and go, is that molecule present in that atmosphere? Obviously, that's a lot easier when you've got a really thick atmosphere, something like Jupiter. You can be yeah, what a really strong signal. Something like Earth, which has, this tiny, thin atmosphere, right, that we're all just, cocooned by, but it's just this tiny thing, right? It's not really very thick. It's a very weak signal. And so there's been a lot of efforts for trying to, for rocky planets that we know of, Earth-like planets that we know of, trying to figure out what's in the atmosphere. But the data is just so
weak,
noisy and weak. And yeah, it's amazing what techniques can do. But at the same time, there's a massive argument in the minute, for example, going on about a planet called K2-18b. Fun name, I know, but named after stars. Stars are named after catalog names. So yeah. Which is is it a water world? And does it have this molecule called dimethyl sulfide, which is only produced by bacteria here on Earth or industry? Does it have that in its atmosphere? A lot of people are claiming, yes, it does. The data says it does. And other people are no, you can describe the same data with a flat line. There's nothing there. So it's a really interesting debate that's going on.
Interesting.
But it raises this question of even if we did believe we'd made that detection of here is this thing in a planet's atmosphere that points to life, doesn't necessarily mean that there's life there. Because it
could have been.
It could have been, or even there could be some chemistry that's going on that we don't know about.
The early stages of life.
Yeah, exactly. And I think this is one thing that people don't think about is the timing. Because if you think about Earth's been around 4.5 billion years. We've been around a few 100,000 of that, maybe. Life has been around for a long time, obviously.
I struggle to even what do you do with these numbers, right? I can think of 50 years, maybe 200.
Yeah.
But what does it mean when you say these numbers?
Okay, the best way I always think about it is actually in time, right? Is if you think about I think it's a million seconds is around
that's a good
week.
one. That's a good one.
But 30, a million seconds is around a week, but a billion seconds is around 30 years.
Yes.
Right.
No, it's even longer than that. Yeah, I think it brings you back to the 17 or 1800s.
Okay. Yeah.
Yeah, so if you rewind a million, God, is it seconds or minutes? Maybe that's why. Maybe you're doing seconds.
Yeah, maybe I do seconds, you do minutes. Yeah. But that's insane.
But yeah, okay, so how do you, what's your trick? So that's how you measure this.
That's how I measure it, yeah. And that's why, when they talk about if you put the Earth's history on a clock, right, we've literally been here for the last 2 minutes or something of a 24-hour day.
When you say put on a clock.
Oh, so if you put the 4.5 billion years of the Earth's history into a 24-hour day, I think humans have been around for the last minute. If that, we've barely been around. And if you think about how long we've been either sending stuff to space or looking at the stars and actually able to make sense of them. It's only in the last 100 years we knew that other galaxies existed beyond our own. We thought the entire universe was just our Milky Way galaxy of a few 100 billion stars. So when you think of it like that, in terms of how long we've been around for, the likelihood of not just there being life elsewhere in our galaxy, but also that it would be at the same stage of evolution as us.
Same point of time.
It might have already, it might still be evolving. It might be amoeba. It might have evolved and peaked and already crashed again and, wiped out its planet or something like that, right? So when I think about sort of do I think life exists out there in the universe? I'm yes, I think it kind of has to in terms of the statistics of there are hundreds of billions of stars in the Milky Way. The sun is just one star.
Yeah. And you're not saying that there is life outside this planet right now.
No, that's the thing. Yeah. Exactly. Yeah. It's it doesn't have to be.
So you're hedging in a way that really gives you a lot of flexibility.
Exactly. And also if you think about how many galaxies of stars there are beyond our galaxy, the latest count puts it at around 2 trillion in the observable universe, and they all have 100 billion stars. with planets,
something's going on.
Like something is going on. We cannot be
Right.
the only ones. I think it would be just like arrogant of us to assume that we're the only place that like the right conditions for life were there. But also like it might be life not as we know it. You know, it might need some other solvent instead of water to evolve. You know, it might be sulfuric acid or something, you know.
Maybe
it could be
they like
anything.
alcohol and they live off alcohol.
Yeah.
You know?
So, we have this thing in exoplanet science, which is called the habitable zone, which is like the Goldilocks zone, you know, where it's like, it's not too hot and it's not too cold for life.
Right.
If you had a planet there around a star. My PhD supervisor has a thing called the really habitable zone, which is the zone in a galaxy where you would have the molecules to make alcohol and quinine and citric acid so that you could make a gin and tonic.
Nice. And protect yourself from malaria.
There you go.
Oh, win-win-win in case the
Win-win.
mosquitoes hang out.
And also scurvy.
It's true. What is, since you're an evidence-based person,
Yeah.
what is the strongest level of evidence that there is life outside of our planet?
Yeah. I don't
Is there any?
think we have any at the moment.
None.
No.
So like not light somewhere, not a
No.
Goldilocks zone, nothing.
Nothing. And this is the thing, the burden of evidence for proving that there's life elsewhere is huge.
Do you think maybe not just the US, the UK, et cetera, are hiding evidence of aliens?
No, not at all.
Why?
Because I don't think you'd be able to keep that secret. Because I think scientists, if we ever discovered that there was life that had visited us here, would absolutely shout about it from the rooftops. And I think what happens with misinformation around this topic is really getting across the difference between actual alien life versus what is a UFO. A UFO is just unidentified flying object. It could quite literally be anything. And there are so many phenomena that we don't understand and we haven't explained yet that it, you know, you see these things, oh, it's a video of like a ball of light and it's moving. Yeah. Have you ever heard of ball lightning or like plasma balls and things like this? Like
What?
they just, they're a thing, right?
Hit me?
Yeah.
Plasma balls?
Plasma balls are a thing.
What's a plasma ball?
So a plasma is, we talked about, right? It's a gas that's been charged. So you're taking the electrons away from
And they're kind of
like
free
the
floating
atoms
now.
and they're free floating. Yeah. And so when that happens, you can, when they travel through the atmosphere very fast, you can actually get light from it. You can actually make this. I wouldn't recommend doing it. It's one of these things like, don't try this at home, kids. Maybe look up a YouTube video of where you can make plasma balls like in a microwave with like two grapes next to each other because they have like ions between them that create this. And it's the most bizarre thing you will ever see.
Why are grapes doing this?
I actually don't know why grapes. I don't know if it's just because they're small enough to fit into a microwave or if it's like the specific nature of the skins perhaps gives it like an ionization potential between it. But it's grapes. But it looks bizarre, right? It's like it moves in the most like alien, for want of a better word, way, like some way that is completely foreign to us because we don't experience plasma day to day. We have solids, we have liquids, we have gases. We don't have the kind of like temperatures that you need or like pressures or whatever for plasma. And so it's one of these things where it's like if you have the right atmospheric conditions though, then this can happen. So that could be one explanation
So
for a
you're
lot of
saying
UFOs.
it's the noise that you hear late at night at your house. The odds are that it's an intruder is very low. It's probably the wind, the creaking wood, the plasma ball,
Yeah.
something else.
Exactly. And that's why I think just like the burden of evidence is so high. It's this like the, if you say this all the time, right? It's like if you hear hooves, it's horses, not zebras, right?
Which is imperfect, by the way.
Sure. Cause sometimes it's zebras.
Yeah. And you have to not write off and keep the zebras in mind.
And it's based on your prior of, where are you in the world? Cause if you're in Africa, it probably is going to be zebras.
Yeah, for sure. Easily.
Some parts anyway.
Yeah.
So if you're in Serengeti National Park, it's probably zebras.
So you got to think about it.
Sure.
Yeah.
But yeah, the burden of evidence for finding life in the universe is very high, but also it's just kind of like if something like this, we did have evidence of something that was crashed, I don't think you'd be able to ever keep it secret, especially not for as long as it's been claimed to be and things like this, So
And then 1 to 10, how fake is the moon landing?
what's my scale here? What's 1 and what's 10? Because basically the moon landing is not fake.
1 is plasma ball and 10 is dwarf planet.
Still doesn't make any sense, Mike.
Well, that's exactly right, given the fact that this conspiracy theory doesn't make sense.
This conspiracy theory doesn't make sense at all. Exactly. And I think it's one of those things, it's just, again, a massive misunderstanding of like, yeah, people are like, but we sent astronauts in a tin can to the moon. It's like, yeah, because that's all you needed. we like propulsion is a solved problem. You literally just need to throw something that way to go that way, right? And you didn't need like computers to do this. The maths is something we've known for a very long time. And yet it was a lot of effort by a lot of people, but it was doable. And again, this is just, if it had been fake, you don't think Russia would have been like, actually it was fake, they didn't beat us. You know what I mean? Like it's just, it's one of those crazy things, right? And I know that it is bizarre that we did this before a lot of the modern technology that we've become to be so reliant on, but it just was really that simple as just fire something up on a load of fuel and you'll go that way.
Do you have to answer that question sometimes on your social media? Do you get it?
Or
are you past it already?
I feel like I get a lot more flat Earth than I do moon conspiracy.
In what sense?
I get a lot of space is fake, the Earth is flat, like NASA and all scientists are lying to you.
Oh.
And I'm like, okay.
Where do you think that's coming from?
I think it's a mistrust of government. I think it possibly stems from because a lot of space research is funded through government agencies like NASA and ESA. Obviously,
and is that because there's not much profit to be made? So like capitalistic companies are not going to go invest in something they can't monetize?
Probably, yeah, something like that. But it's just, I think what's strange about it is you see people like doing experiments that they design. Like, we're going to show that the Earth is flat, and they design it in this specific way and they send it up, but then they're almost ignoring the evidence that's then in front of them.
Like what? Give me an example.
I mean, I don't really engage with a lot of this content, so
that's
I probably can't think about it.
See, I don't have a choice these days with all the vaccine stuff that's happening.
That is true.
That
you
is
have
my
to
flat
do
earth.
it. This is the thing. Yeah, like I think the vaccine thing has become so like mainstream and widespread that so many people are talking about it that you almost have to.
Yeah, like I try and think about the one difference between the two subjects in that those who disbelieve that the Earth, or those who believe that the Earth is flat, don't have any negative repercussions to their daily lives from that belief.
Yes.
So they can believe it. They can feel happy about it. No one's going to really challenge them on it.
No.
But when you disbelieve in vaccines, in germ theory, you start creating negative impact, not just for yourself, but for your own children, and then for society as a whole, because outbreaks start happening, then viruses mutating and start impacting other geography. And because we're so interconnected as a world these days, what happens here happens there, what happens there happens here.
Yeah. So it's so important. And I just tip my hat to you for that respect, because I mean, we have the luxury of just kind of being able to ignore it a little bit, It is funny because, like, for example, in the UK, we have the BBC. They have to be impartial. The amount of times that me or my colleagues have been like rang up being like, oh, have you seen this like flat earth news thing? We're going to get them on. And then obviously because of impartiality, we want to get someone to debate. And I'm like, no, it's not a debate. Like, this is something that the Greeks proved.
Do you think that it's not a good idea to debate flat earthers? Yeah.
Because it's like, don't engage in a kind of a way, It's just kind of like there are better uses of our time to not engage, when it is simple enough as to prove that the Earth is round, to say, hey, I have a well in Alexandria and you have a well in Athens. At what time does the sun directly shine down your well? Oh, our time is different because we're around the Earth. The Earth is round.
Right.
Like it's not something that's worth time. It's not a debate. Therefore we don't debate, if that makes sense. And this is the funny thing about flat Earth is if I've seen some stuff where you talk to them and they're like, well, what do you think about like Mars? Is Mars flat? And they're like, oh no, Mars is round. We can see that. And I'm like, so why don't you think the Earth?
The consistency isn't there.
Exactly. Right. Okay. Yeah. And so this is one of these things.
Have you ever heard a really good conspiracy theory about space?
Oh, no. I'm trying to think.
You just went full on no.
I'm like, no. I did enjoy the. Do you remember when they launched a Tesla into space?
Yes.
Yeah. There's a scientific hypothesis called panspermia, which is that all life in the universe has a common origin, and it's traveled between star systems on things like asteroids, and like life on Earth was seeded when, say, an asteroid impacted with Earth, and
interesting.
Like life was spawned that way. So like little bacteria came to Earth on an asteroid, for example. It's not a proven idea. It is just an idea.
Okay.
When the Tesla was launched into space, we were like, oh, did we just accidentally start panspermia? Did we just send bacteria on a Tesla into
But wait, there's
space
also
that's
bacteria on rocket ships, no?
Well, yeah, exactly.
Yeah.
But it was just kind of like most of those things that are launched into space go through really, really strict like decontamination protocols, for example.
Oh, they do?
Yeah. Like if you send a
So
rover.
if you send a rocket into space and you didn't wash it, that's like bad form?
Yeah, well, think about it. Like if you send a rover to Mars, right? You send like the Curiosity rover up to Mars and it's going to explore Mars for like a decade,
Right.
you know? And it has like a little tardigrade, you know, a little like tiny life form that we know can survive the vacuum of space because we've tested it on the International Space Station and stuff. And you send it to Mars and then a decade later, you're trying to prove is there or was there life on Mars and you find evidence of that. You're like, well,
Did I create it?
Did that come from the rovers we've sent? This is why I actually don't think sending humans to Mars is a good idea because I think we then, like if we're ever going to answer that question, there'd always be the question of, well, was it because we sent humans and it was like, you know, human waste or something?
Everything.
Well, yeah, we carry a lot of bacteria in our bodies. So, you know,
there's a whole galaxy of that in there too.
Yeah, exactly. So that's one of the big issues, I think. And so I don't think that Tesla went through the same strict decontamination protocols that perhaps other agencies that would have launched stuff would have gone through.
That's so scary.
So I like that sort of like fun. It's not really a conspiracy, but I think it's a fun musing of like, did we accidentally spawn the universe with life by sending a Tesla into space?
Yeah, because we've
for a
sent
PR
animals
stunt?
into space, right?
Yeah.
There was a dog. Monkey or something.
There was a dog and a monkey that both went up in the early space race just to prove that you could survive the G forces. They were sadly never brought back to Earth. They died in
why
space.
didn't we bring them back?
Because we didn't know how.
We didn't know how.
It was like possibly we did, but it was kind of like we didn't know if they could even survive being brought back in terms of like re-entry into the atmosphere and things like that. So it was kind of a proof of concept that you could go up at all and anything could survive being sent up. So yeah, space isn't exempt from the horrors of animal testing either.
Yeah.
So
speaking of conspiracy theories, tell me about Atlas.
3i Atlas.
3i
Yeah.
Atlas.
Oh my God. So this is one of the coolest things that's happening, I think, in astronomy at the moment. Is it's only in the past couple of years that we've found what we call interstellar objects. So basically like an asteroid or a comet, but not from our own solar system. So it's like from another solar system. It's like formed
Crossing over.
around another star. It's been like ejected out of that solar system because, you know, as things are forming, you've got lumps of rock all clumping together and they like interact and they get thrown off, some of them. Kind of like, you know, like when you play pool and like they can collide together and like one ball goes flying off, one ball stops kind of thing. So it's gone flying off. And now we've spotted them coming through our own solar system. Like we've observed them and we've gone, okay, we've seen it there that day, there that next day, and then there. So we'll work out its orbit from that. And we're like, oh, hang on, this is not orbiting the sun. And we realize it's coming from somewhere else. And we've seen only 3 of these things so far. And the third thing literally has only been spotted a few months ago. And it's 3i, the third interstellar object. And it was spotted by the Atlas telescope.
Okay.
And it's very, very cool. And it has obviously been latched onto by a lot of conspiracy theorists and misinformation online and things like this. I think because of well-meaning scientists publishing things where they're like, well, there is a possibility that it could be an alien spacecraft. Let's figure out whether it is, you know?
Yeah.
And all the information we have about this is its brightness and how it's moving and things like that. And that's what we're having to go off. And they're saying, oh, well, you know, it could be, you know, because of this specific property, could that be, you know, a different material to like an asteroid that we've necessarily considered? But of course, when you publish things like that, they get latched onto, they get completely...
The headline gets twisted.
Exactly, yeah. And then, you know, it's like a game of, you know, sort of like the whispers game, or, you know, like whispers where you pass on like information and
Telephone,
it gets complete telephone. Thank you. Like it just gets completely warped, right?
Sure.
So there's a huge amount of misinformation there. But these things are so, so cool because they allow us to ask so many questions that we can't just ask by studying like asteroids and comets in the solar system. Because we talk about asteroids as being like rubble, like left over from the formation of the solar system that didn't make it into becoming a planet. So they're kind of like fossil records of like what happened like 4 billion years ago and things like this. And so we have that fossil record. And then when you have another object come in from another star system, you think, well, that's a different fossil record we can then compare to and say like, have things evolved differently in different star systems to give you different like properties and different features of the rock. There is a big question about whether they get completely like annihilated by radiation passing between star systems and
God.
does that completely like, invalidate everything that you look at? We don't know. And it'll only be by finding more of these things that we figure out, what do other star systems look like? And can we even pinpoint it to a different star system and stuff
Would
like
we
that?
ever go out and capture it?
Good question. There have been, maybe not capture it, but send a mission to one, maybe like impact with it, because by impacting with it, you can like throw up a load of sort of like the dust on the surface, and maybe you can try and like capture that. So there was a mission that did do that, sort of like almost like what I say, like high-fived an asteroid to throw up a load of stuff and then brought it back to Earth. So maybe we could try and do that at some point, and that would be very, very cool. The problem is we don't get much warning for them because they're interstellar travelers, they're moving really quite fast and they're sort of coming directly at us. And so they sort of loop around the sun very quickly. So mobilizing for something like that.
Got it.
Usually if you plan a space mission, it's going to take 10 years before launch kind of thing. And then how long it takes to get there. But there is plans in place to sort of have one ready for the next one that we spot.
Okay.
But it is very, very fun. Like I was in the office the day after it was discovered. Or it was like overnight in the UK. So someone literally came in at like 9 o'clock in the morning, got to their desk and realized this had been spotted overnight. And they like ran to my colleague's office next door, literally just shouting like 3i, we've got 3i, and it's just like, it's so much fun seeing the joy in people's faces when a whole new field of science is created by spotting these things,
Wow. What's an emergency in an astrophysicist's office?
Depends what field you're in. An emergency can be like, usually like if a supernova goes off, if you're a supernova person, it can be like, quick, mobilize, got to get another telescope to point at this thing,
Okay.
And it's like, who's on what telescope in Hawaii right now? Can we call in a favor? All that kind of stuff. That can be a bit of an emergency. If you're in that kind of what's called a transient field. So something that changes in the sky. But obviously the classic one would be asteroid impacting with Earth kind of emergency.
Typical movie
script.
Yeah. Cool. Back to the interview in just a second, but first I want to tell you about this video sponsor, Garden Health. Colorectal cancer is the second leading cause of cancer deaths in the US. And what makes that especially frustrating is that many of those deaths could have been prevented with screening. As a doctor, I'm always going to recommend getting a colonoscopy first and foremost. It's the gold standard for colon cancer screening as it can find and address even pre-cancerous polyps. Despite this, many people are not up to date with their colonoscopies, and the most important thing is that you get screened. There are less invasive colon cancer screening options available too. One is a stool-based test. You collect a stool sample, send it to the lab, and get your results. Another option is a blood-based test like the Shield blood test from Garden Health. It's an FDA-approved screening test for colon cancer that you can do with an easy blood draw during a routine doctor's visit. When screening is easier, more people follow through. In fact, blood-based colon cancer screenings have shown around a 90% adherence rate. That means 9 out of 10 people actually complete it. So if you're 45 or older, talk to your doctor about your colon cancer screening options or learn more about the Shield blood test by visiting shieldcancerscreen.com. Also, for important product information, including precautions and limitations, please visit shieldcancerscreen.com. Shield is FDA approved and available by prescription only. All right, let's get back to the interview. On your social media, since you're not engaging with flat earthers, are you engaging with misinformation at all?
Yeah.
Or are you doing primarily education? Like, what is your goal with the social media?
Yeah, I mean, I think it's mostly just sort of like educational. So if there are like comments where people have like misunderstood something, I'll try and like follow up on that, and either in a reply or a comment or even like a short form or something like that, when you reply. But I think it's not my job to prove to flat earthers that the earth is round. I think that, like I said, it's like a waste of time that you could be talking to someone about a valid scientific theory that's really, exciting. And I think my job, what I like to think of it as is like, most of the time when they engage with space content, it's usually because there's been some new discovery or a new telescope launched or a new image from a telescope. And then, a journalist will cover it for some news site or news channel and do a great job of the sort of like overarching coverage. But people might be like, yeah, but how did they, get that or whatever? And so I'm sort of cutting out the middleman. I'm like, come to me to find out how we did this,
right?
Or the why we're even doing this. And it's sort of like a connection between people who, perhaps were like interested in science, maybe did science at university.
Astro curious.
Yeah, exactly. I think there's a lot of people that love space.
There's a lot of people that love space.
And never lose that curiosity as they get older. But, they didn't do what I did and keep following the physics path or whatever.
Sure.
And they did, go out and do something else, but still want to keep that connection. Like what I feel like I do is kind of like, we have things called journal clubs in academia where we're like, oh, this new paper came out. Shall we all talk about it and just chat? And what do we think of the idea? It's kind of that, but between me and like the audience, the public. And so I think that's kind of my role, is to be that like in for people into the field. I mean, I'm doing what you're doing, but for astro instead of medicine, right? So.
And what questions are people asking you? Are they asking you questions that are hypothetical, or more so things that they've seen happen in the news? What's the breakdown there?
A bit of a mix. Yeah, I get some crazy like hypothetical questions.
Yeah, like what?
If we crush the Earth down into a black hole, how big would it be? Like if we made a black hole in a lab, would we all get sucked in? But then also things like, why doesn't dark matter, which is matter we can't see because it doesn't interact with light in any way, like why doesn't that make like dark stars and dark black holes and things like this? It just kind of stays in fuzzy balls. Why is that? And it's like, well, we think because of this. We don't know. Right. We don't know exactly what dark matter is, but what we do know of it, we think it's this reason. So it gets like as in depth as that to like fun sort of like, if I fired a potato into space, how long would it take to come back down?
Sure.
Silly things like this.
The what if questions of
exactly.
the world.
Yeah, exactly like that.
What is your actual job? How would you summarize if you were writing a 1 or 2 sentence resume summary?
Yes. So I like to say that I answer the questions that we don't know the answer to, specifically on how supermassive black holes grow. So we think there's a supermassive black hole at the center of every galaxy. How did they get that big? Why are they at the centers of galaxies? And what process grew them as well?
What's a black hole?
Yeah. That's the $1 million question.
Is that? I feel like you're discounting it. I feel like it should be $1 billion or $1 trillion.
Yeah, well, yeah, exactly. So a black hole is, I like to think that we probably misnamed black holes. I think that actually contributed to a lot of people's misunderstanding of what they are.
Oh, how would you name them if you had to rename them?
I'd name it a dark star, I think. Because black hole gives people a sense of, it is a hole. There is nothing. Exactly. It's an emptiness, but it's the exact opposite. It's literally a mountain of matter is a black hole.
So Black Mountain.
A black mountain. Yes. But then also they're not really black either. We can see them kind of. So they're white mountain. But yeah. So a black hole, the off thing is that it's a region of space so dense that light can't escape.
A region of space.
With so much stuff there. With
so much stuff that light can't penetrate. Leave.
Yeah. So if we think about leaving Earth, right? The reason we can't leave Earth, like if we jump now, we would not leave the Earth's pull of gravity, is because we can't jump at a high enough speed to escape it. Only rockets can. Rockets have to be traveling at 11.
And Michael Jordan.
Well, if only.
Sorry.
Okay, in Space Jam, maybe. So yeah, rockets, have to be traveling at the right speed to be able to actually escape the Earth's pull of gravity. And so they have enough speed to do that, fine. So something heavier like Jupiter, you would have to be traveling even faster to escape from because it's much heavier. It's a bigger planet.
Stronger gravitational
Stronger
pull.
gravity, exactly. So imagine just like keep piling matter onto a planet, until it gets...
Is it a speed that you have to surpass or an acceleration that you have to, or is there no difference?
Usually you have to accelerate until you hit a certain speed. But if you don't accelerate fast enough, when you're escaping from a pull, if you're starting stationary, then yes, you have to reach a certain acceleration. Otherwise, the gravity will still overtake you. But at the end of the day, it's
about a speed that you're looking for.
Yeah.
Okay, got it. So it's not a continuous acceleration that you need to get out.
It can, for the Earth, yes, because gravity is an acceleration at the end of the day. Yeah. But in terms of a black hole, really, you would be thinking in terms of speed, not acceleration.
Okay, got it. Yeah. I'm just thinking for my future escape.
Sure, got it. Yeah, just so you know. Yeah. So yeah, with a black hole, what's happened is you have so much matter in that place that the speed that you would need to be going to escape the pull of gravity backwards is 300,000 kilometers a second. That's about 186,000 miles a second. And there's nothing in the universe can go faster than light. That was what Einstein showed us is that it's like a speed limit in the universe. And as you approach that limit, physics starts to go really weird. Like as you put, to go faster when you're like running, to get faster and faster, you have to put more energy in, right? Like a lazy jog is not as energetic as like a really full on sprint, right? When you get up close to the speed of light, you can put more energy in, but you won't go faster. Instead, you'll get heavier, which is bizarre
of
relativity.
Yeah, I'm starting to think of Earth's situation because you're thinking you're running against air molecules,
right?
But in space, that's not an issue.
No.
So what is creating you to become heavier?
That's essentially what Einstein's theory of relativity tells us. And it's one of those things that
Clearly
I
studied
think
this extensively.
It's fine. I wouldn't have expected. This is the thing. I like thinking about relativity every day and it's like no one else does.
Yeah.
But it's one of those things that I don't think we really understand fully why necessarily. Like I could show you an equation that's like, this is why it makes sense. And this is pulled out of all of the things we know about like time and space. But in terms of the why, it's just because
it happens.
It happens. Yeah. And it's a bizarre thing. And so it means that once you've hit a certain like density, the gravity is so strong that you physically cannot go faster to escape it. So matter gets trapped there, light gets trapped there. And we don't really know what a black hole looks like because of this, because all of that information comes from light.
And where are we finding these black holes that we even are aware of their existence?
Yeah, so we find them in a few different places. So stars, when they die, some stars, some very, very massive stars, the cores of the star will collapse into black holes. And so we've seen them if you have, say, two stars, what's called a binary star system, where you have two stars that formed and they're orbiting each other, and one of them has already gone supernova and died and made a black hole. You can see the pull of it on the other star. And so we know that it's there. But then we also know that there are supermassive black holes at the centers of galaxies. So instead of something similar in mass to a star, so say like 3 times heavier than the sun, 10 times heavier than the sun, a supermassive black hole is anywhere from like 1 million to 50 billion times heavier than the sun. So they are quite literally supermassive.
And if we can't see them, we're just watching their impact on other structures.
So we can do this, for example, with the Milky Way galaxy. Our galaxy has a black hole at its center, which is 4 million times heavier than the sun, which we've worked out is there because we've watched the stars in the middle of the Milky Way, like right at the very center, not get pulled in, orbit the black hole. So like how, that the sun is pulling on Earth, but Earth is in a stable orbit, so it's not going anywhere, right? The stars
but what
are far
keeps
enough
it in
out.
that stable orbit if the black hole is actively exerting some force?
But the black hole is like in the sun in that scenario. The sun is exerting some force on Earth, right? But we're not being sucked towards the sun. Even though the sun is massive, it is huge. The Earth is not being pulled towards the sun, okay?
Why is it not?
Well, it is, but it's being pulled in a certain way that it keeps it on a circle orbit, right? And so unless something like took energy away from the Earth or like nudged it slightly to give it extra energy, we wouldn't change that orbit. And the same is true for stars. So the sun is technically orbiting the center of the Milky Way, the black hole at the center, but it's not, even though there's some pull there, it's far enough away that it wouldn't get like sucked in. And the same is true for the stars in the center. So the closest one orbits at about 12 light years away. So it'd take light 12 years to go from the black hole to the star. And that's far enough away that even though it is being pulled towards the black hole, which is keeping it in orbit, it's not getting sucked towards the black hole so that it would fall in. So because we see it's like full orbit around the center, and we plot that orbit out, we can then go, so the thing in the middle has to be this big to make it go that fast in its orbit.
I see why you want to call it a dark star or a black star, because it's functioning as the sun, just without the sun.
Exactly. Yeah.
Interesting.
And this is the thing. I think that's what comes with the misconception is people think of them as these massive vacuum cleaners, just like, sucking everything up. But it's the same thing. It's like, this is why I say, if you could make a black hole in a lab, do it. Because it would, how much mass are you going to be able to squish down in the lab? 10 grams? You're going to feel the same pull from a black hole of 10 grams as you would anything of 10 grams, a few ounces.
So the thing that makes a black hole, the thing that gives a black hole its potential energy exertion is based on its mass.
Yes.
And because it has so much mass.
Yes.
And is that because these stars are huge or because it's a confluence of all these stars?
So it's because of how dense the it's because of how dense the black hole is, but in terms of the stars that make them, the core that's left behind in a star, so where all the fusion that turns the hydrogen into helium that gives out light that powers stars is happening, all of the hydrogen's been used up. You've just been left with helium at the end. And then what does it do next? It's kind of like, okay, well, it can maybe fuse helium into heavier things, but eventually it sort of reaches the end of the line when it comes to you have enough energy to keep fusing things together. And then there's no process making energy to push outwards against gravity. So like a star, for example, is, the sun is very, very big, right? It's 10 to the 30 kilograms or something crazy, right?
I have no idea how to conceptualize
a one with 30 zeros after it and then kilograms, right? And people are like, can you translate that into imperial? And I'm like, it would still be a lot of zeros.
How many elephants is that?
So if you have like that big of a thing, think that gravity is pulling in on that all the time, but it's got fusion in the center pushing outwards. And so to make a black hole, you basically have to get rid of the thing that's pushing outwards against gravity so that gravity sort of starts to win and will collapse everything down to make it so dense that all of a sudden, whatever's happened to that material, it's become so dense that light can't escape. But we just don't know what then that looks like anymore,
Because we've never visualized it.
No, because we can't, because no light can get to us beyond what we call it the event horizon, which is like
the ending event of the star burning out?
Yeah, exactly. It's the diameter of the black hole, basically. It's like the radius of what you class as inside here is the black hole. And if something crosses that line, it's never coming back. And we can't see what's inside it. But we know all the material that was in the center of the star is trapped in there now.
So if you shot a drone into the black hole, what would happen to the drone?
Well, if it could survive the gravity, because the thing is, the gravity gets so strong that you get like the difference in the gravity between one side of the drone, like closest to the black hole, and the other side would be so great that it would get stretched out. It's called spaghettification. It is perhaps my favorite word ever. Spaghettification. It is a real physical terminology that is used. That is
I'm going to use that in a reaction video when we watch someone get pulled apart. Oh, it's a spaghettification of the human body.
Got spaghettified. Yeah. It's just so much fun to say. So it would get spaghettified as it got close to the black hole. It would just be this trail of atoms, sort of slowly falling in. But essentially, if it could survive that, it wouldn't notice anything. It would cross the event horizon, wouldn't know it had crossed it. But it wouldn't be able to get out again. So this is the thing.
Interesting.
And it would be able to see what was beyond the event horizon all of a sudden. All the light and material that had been trapped in there, it would then be like, oh, I can see it now. But it wouldn't be able to tell us. It wouldn't be able to send a signal back to be like, this is what I'm recording. Because any signal it sent out would never make it to us.
Because it gets pulled back.
Yeah. There's a thing that says that it's a really weird thing. So we talk about space-time in astrophysics. So there's 3 dimensions of space and then another dimension of time. And in the same way that you can move through space, do you move through time? They're all intrinsically linked. In a black hole, it's like if you move in a direction, you're actually moving in time because the only path that you have is that your future will end up at the very center of the black hole. Yeah.
Kind of like human life. We all end up in a black hole in some ways.
Sure.
Usually buried. But
okay. I see where you're going. Yeah.
There is an absence of light. I can say that as well from a medical standpoint. But okay, so you have that. And there is no black hole that ever develops on the Earth.
Not that we know of. No, there was one of the big things that in our field that was the sort of big miscommunication thing that we had to be like, no, it's going to be fine, was when what's called the Large Hadron Collider in Switzerland in CERN turned on back in the 2000s. So it's a huge particle accelerator. It's a big tunnel that's underground that goes, it's miles long, this huge circle that goes all the way under the city of Geneva and out into France and back round again. And basically it's so big because they accelerate particles up to near to the speed of light in the tunnel.
And why do they do this?
They collide them together and see what pops out again. So that they can understand particles better, basically.
Sounds safe.
Yeah, it is very safe. When it's switched on, people were like, they're going to make a black
question
hole.
vaccines and there's a giant particle accelerator underneath France and Switzerland?
Yeah, exactly.
You have way bigger things to worry about than 5G cell towers, folks.
I love that. Well, this was the thing though. When it switched on, people were like, the energy's so high, you're going to make a black hole. And the whole Earth's going to get sucked into a black hole. And people had to come out and go, first of all, the energies are not high enough to make a black hole, because you'd have to have something like a billion times higher than the energy that you create in the particle collisions in the particle accelerator to make a black hole. So not going to do it. And B, be kind of cool if we made a black hole, because nothing would happen if we did, you know?
It's too small?
It's too small. So if you did, it would be like particle sized. So if you take a few particles and collapse it down, it'd be tiny. So something like a kilogram black hole would be smaller than a proton, which is like smaller than a hydrogen atom, basically like the center of a hydrogen atom.
What happens if you shine light on a black hole?
Gets trapped there and you never see it again. Yeah. So.
Wow.
Yeah, this is the thing. So it's just crazy how much miscommunication there is around it.
Even if it's really small.
Yeah, even if it's small, it would just get trapped.
Still captures.
So it would just a tiny bit would go. So, and the thing is, like I said, even if it was a kilogram, it would have the same pull as anything, that was a kilogram, like a bag of sugar, right? It would have the same pull as a bag of sugar. You're not getting sucked towards a bag of sugar. You won't get sucked towards the black hole. It would only be if you got like too close, and too close for a black hole of something smaller than a proton, right? It's like you'd have to be on a quantum level to get close enough to it. Wow.
So for people that are listening that are probably experiencing a black hole in their mind right now.
Yeah, I have that effect on people.
What? I give people a few pillars of things that they need to know about and take seriously about their health. And usually it's not mind-blowing. It's what grandma told us. It's accurate over generations, which means sleep well, eat moderation, that kind of stuff. What should be 3 things that everyone knows about a black hole?
That we're not going to get sucked towards a black hole. We're not in danger from a black hole. Black holes don't suck things towards them. They just act like any other object in space. It's only if you get too close. The second
thing, you see a black hole, run.
Yeah.
Or it doesn't even matter.
It doesn't even matter. Doesn't even matter.
So you're going to either succumb or it's not going to do anything.
Yeah. If you're that close to see a black hole, you're probably too close anyway. So yeah. And there's nothing close enough that's going to be a danger to us either.
Okay, good. So we're safe from black holes.
We're all good. Nothing to worry about.
That's the title of the podcast.
Do not
you are
lose
safe
sleep.
from black holes.
Yeah. Do not lose sleep over a black hole. The second thing I think I want to get across to people is that we weirdly can see them. We can't see the black hole itself, but
from the absence of them.
Yes, but also material around a black hole is accelerated to such huge speeds by the black hole's gravity. Like if it is sort of like going to eventually fall in, it kind of falls in on such a slow spiral that on its way down, it's accelerated up to such a huge speed that it starts to glow. And then we can see it with like ultraviolet ray, X-rays, even invisible light. And so this is how we tend to study a lot of black holes, is because we can see what's going on around them. And from how hot something is and how much light it's giving off, we can tell a lot about the black hole. We can work out how heavy it is. We can work out how fast it's growing, so how quickly it's taking in more material of the stuff that's actually gotten close enough to it in the first place.
Are there many black holes that you're aware of that you already have identified?
Well, yeah. So we think, pretty much like 10% of all galaxies have a supermassive black hole at the center that's growing. So we think all galaxies have a supermassive black hole in the center, but 10% of them have growing ones that we can see. And this is the kind of thing that I study.
Are they like tumors of the solar system?
They're more like volcanoes. Like they're active or they're dormant. You know what I mean?
Trying to find
no, they're a bit more like a medical analogy. Yeah. I see what you're saying. Like some people have them and some people don't, but it's more like
and some tumors are benign and some are
yeah. Okay, fair. Yeah, some of them. So we think all black holes will grow at some point in their life and will take in material. It's just 10% of them at any one time seem to be growing. Lighting up.
Got it.
Yeah.
And do you have a favorite?
Ooh, TON 618. Again, great name.
TON
618. It's the heaviest. That's why it's the coolest. It's 50 billion times heavier than the sun.
Is it also the oldest?
Could be. Yeah, to be that big. Could be one of the old. It's not like the oldest in terms of like the most distant that we've seen or anything like that.
Oh, I see. I see what you mean.
I think maybe technically the oldest would be like
the
Milky Way. No, the Milky Way's black hole, and the fact that we're seeing it like after 13.8 billion years of evolution, whereas other supermassive black holes in galaxies we're seeing, even if it's 100,000 years ago versus a billion years ago kind of thing, we're always seeing them a while ago because light takes time to travel to us.
That messes with the mind so quickly. Okay, so third thing you must know about a black hole. Wait, let's recap. First is you're not going to die.
No.
You're safe from black holes. Two, that
we can see them.
We can see them. That was misinformation. And three?
It's really difficult to grow them. Like people think of them again as like vacuum cleaners. And, you know, you talk about like getting material close enough to them so that they can use that to grow heavier and, you know, take in more mass and trap more mass inside the black hole, the mountain, the star, you know, the dark star. But actually getting material close to them is really difficult because, first of all, of just how mind-bogglingly big space is one thing, but also like the process to actually get material falling in. Think about like how we said before, the sun is orbiting the black hole at the center of the galaxy. We're not falling into the center of the galaxy. We're on a nice stable orbit. It's the same is true for hydrogen gas, the stuff that will make new stars, but also feed the black hole that's just hanging around the galaxy, which you can see when you look up on a night sky. You see the Milky Way, that sort of like glow of like someone spilt milk across the sky. That's kind of like the glow of our galaxy, the gas in it, or the dust that's in our galaxy. That kind of stuff is also on a nice stable orbit around the center.
So if they're stable, why are 10% of them growing?
Well, this is the thing. There has to be a process that sort of nudges the gas, either takes some energy away so that it can lose energy to get off its stable orbit and slowly fall to the center. And so one idea we think is when two galaxies merge together or collide or even just like fly by each other and like really like pull on each other with their gravity, that can send sort of like scramble things up and send stuff tumbling towards the center. But a lot of my research is proving that that's not the only way this happens. It also happens like in a galaxy like the Milky Way that is kind of just being left to its own devices. It can naturally also flow material towards the center along these pretty spiral arms that we see in galaxies, this like spiral shape. They can act as like a funnel towards the center. And that kind of like slow and steady sort of like growth, like tortoise growth is what I call it, as opposed to like a hair, like, you know, like with the mergers of the galaxies, which is like a big firework of a growth. This slow and steady growth is what can actually grow them over billions of years to be that big.
Overwhelming.
Very. Yes, but so cool. And it's why I love black holes, because my little fact file of a book I had as a kid was just like every other page had an image. You know, when I got the black hole one, and it was like artist impression, and it was just this like black circle. And I was like, oh, that's boring. You know, and now we actually have an image of a black hole. We have two. We're taken because of the Event Horizon Telescope, which basically combined telescopes all around the world to make an Earth-sized telescope. Wow. And we managed to take the image of like the disk of material spiraling around the black hole. And it looks like an orange donut, but it's still a really cool picture of a black hole.
Can you be my doctor for a second? Why, when I hear, I'm feeling it a little bit now, but mostly when I feel it the most is when on a night where it's dark, I look up into the sky, I see stars, I freak out.
Oh, okay. So you have the existential crisis reaction. Okay. So there's two reactions you can have when looking at the sky.
Thank God.
There's the, oh my God, I'm insignificant. Nothing I do is, you know, worth anything. I'm tiny. What's the point?
Right.
Yeah. Then there's the other thing that's like, oh, nothing I do is significant, so it's totally fine.
Well,
you know?
I don't think about my significance. I think about how easy I can float away.
Oh, right.
The floating away
You're freaking out because you're like, this rock isn't enough to hold me here.
Yes. Like how long until the black hole starts impacting the Milky Way and its trajectory with another galaxy.
I think, isn't this why people lie on like the floor in the middle of a forest to
but
feel
they're
grounded?
Happy. They feel positive about why do I feel negative? Am I a bad person?
No, I think it's a completely normal reaction because it's so overwhelmingly big, right? And it's so it's so removed from the mundane around us, right? And I think that's you either have the two reactions, right? You either get so freaked out by it or you realize that, you know, everything is fine and there's nothing to worry about almost because you were worried. Like I have that reaction because I'm like, oh, that thing that I've been stressed about because I thought it was important. I look up at the sky and go, that's not important, you know? But I get the freak out aspect of it as well. I get that. But then also, you know, the Earth's a lot bigger than you, you know? So it will, you're not going to float away. You know?
Yeah, I hope so.
You'll be fine.
I really don't want to float away.
Yeah.
That sounds like a really weird, bad way to go.
It does, doesn't it?
Yeah, I just don't want to float away.
Just like
I'll take anything else. Shark attack, I'll
Right.
take it.
Rather than a very, very slow
floating away.
when there's nothing you can
my
do.
God. Yeah.
No.
And you're just, oh no. And you don't even know how long.
No.
Well, I'm sure you'll know.
Yeah. Well, you would know. If you could survive the vacuum of space, if you're in a spacesuit, how long would you have? Like, what, 3 days before you die of like dehydration?
Well, how much oxygen do you have in the space?
Oh, true. Yeah. That's probably the bigger thing. But then, then you would, just like a carbon dioxide.
Yeah, it's like
suffocation.
oxygen and then water, food is least
Okay.
important.
So if you had a spacesuit with a limited supply of oxygen, you'd eventually just go from dehydration.
Yeah, for sure.
Yeah.
That's a pretty quick one too, just because without water or in other areas, methane or whatever.
Yeah. Life as we don't know it. Yeah.
Ammonia that people are using. And I say people very loosely there.
Yeah.
I felt those moments and I struggle to relate to people who look at it with such awe and enthusiasm. Like even I went to El Salvador on a medical mission and I went to a volcano and it's an inactive volcano, but you're in the middle of it. You hike to get in there and then you look around and there's just so much open space. It's uncomfortable. And growing up in the city where I feel like I can take anything and like I box, I get punched in the face. Like these are scary things, racing cars, no fear.
Weird.
And then I stand in a volcano and it's open and I'm just like, what is this pressure?
Yeah, we are exact opposites because I come into a city and I'm like, why am I so enclosed? Why can't I see the sky? Like, I'm like, get me out of these like tall buildings.
Yeah.
And if you put me in a fast car, I'm like, no. Like we're exact opposites in that regard,
Interesting.
right? If you put me in the middle of the volcano, I'd be like, wide open
I'm
space,
home.
surrounded
Yeah.
by nature.
Yeah.
Like I always say, like, do you think things that humans build are more beautiful, or do you think what nature can make is more beautiful?
I'm a human guy.
Yeah, I'm a nature girl.
Yeah.
So yeah.
So I would venture to say that you are more interested in things happening by chance that are special.
Yes.
So would the analogy here be for me to value earning $1 million and for you it would be way more exciting to win $1 million?
Ooh, but then no,
Because that's by
I would still want
chance.
to earn it though,
Yeah,
right?
but that's by chance. And you could say like,
Yeah, but that's a random thing though, right? Rather than like a
everything is random.
True, but like a 1,000,000-year process that's made some really cool rock, I think is way better than like, we
But
built
isn't
this
that
like glass and
random?
steel
It
thing.
wasn't.
It does have an element of randomness.
We're getting into
but
intelligent design. And,
Yeah, I guess so.
I don't want to offend anyone,
True.
but it's just the idea of the Big Bang and everything that has come forth.
But it's
been
that
pretty
aspect
random.
of like, it could be, and it could be the fact that that this is now getting into like the quantum aspect of things.
Well,
which,
that's a good question. Let me ask you that directly. Would you rather win $1 million or earn $1 million? Really?
Yeah.
So you do like the human side of things.
I do. Yeah, that's true. That's true.
So you were saying that the quantum side
Yeah,
of
the quantum
things.
side of things, like in quantum, it's just a word that again gets thrown around by
Yeah,
Hollywood. to be
I don't
like,
know what it means.
We don't explain at this point, but the quantum bit,
Yeah.
it's
Can you-
Marvel movies. Are the worst
tell
for
me what that means.
The quantum means it's talking about like the things that happen on the tiniest scale imaginable, like smaller than atoms, And so on that kind of scale, you get into randomness. And so it's like a weird thing where in quantum physics, I can't actually define where the edge of this chair is. Like,
because it's constantly.
Yeah, exactly. Like it could be here, but there is actually a very small, vanishingly small, but still present chance that it could be like, a kilometer down the road, the edge of the chair, because things can.
It can go that far?
Yeah. Why not?
Well,
it's a very small chance, but it could do. You see what I'm saying?
So it's all based on probabilities.
Yes. And so this is why like no one ever claims to actually understand quantum physics because there's just so much of this that could be weird. But there is this like thought that, the reason we're all here is because we just ended up with the one random chance that did produce the universe.
Which makes it more special. But then can't you use, and I've seen a specific bad actor weaponize this before on stage,
Okay.
say that quantum can be used to explain frivolous, inaccurate concepts because they say, well, why we don't know. It could be.
Yeah, exactly. You can take it too far.
So how do we control quantum? in
True.
that way?
Yeah, I know what you mean. Like, how do you draw the line? I think there's very
Like how
clear
do we say
evidence
that
in-
this chair isn't a block away?
But that's the thing. Like in terms of our real experience, right? We know that we know that it's here. We're talking about like, you know, the one atom in the edge of the chair.
And you know it because your eyes see it, your hands can sense it.
Yes.
But are your senses perfect?
Well, exactly.
And I can play that game all day long,
exactly,
right?
Exactly.
So like, how do we...
But the thing is, I don't think even the maths of quantum physics tells you for sure either, right? It would still just give you a probability back. So you have to be just comfortable with like...
the unknown.
Like it's like 99.9999% likely or sure that the edge of this chair is here because of what I'm being told. But even the maths will probably tell you the same thing, is like it can't be 100% sure that that's where it is. And so when you do study quantum physics, you have to be like willing to
a margin
accept
of error of some kind.
Well, a margin of error is true for any science, right? But it's more like a margin of like likelihood and probability.
Honestly, this translates really nicely back to healthcare. And I'll explain why. I believe my new job as a family medicine doctor in the age of AI, biohacking, social media, dare I say, is getting people to accept the fact that we cannot control our health with 100% predictive ability, prevention, cures, even a diagnosis is not 100%.
True. Yeah.
Yet, when people make content on health, they make it seem quite the opposite.
Yep.
That they can sell you a product that will catch every condition. They will sell you a potion that will relieve all symptoms. Like it doesn't even matter what symptom you have. And what I try and instill in my patients, which is almost dangerous to instill, is that I can't prevent and predict a bad outcome in them within reason.
Yeah.
And I actually saw some negative criticism towards me about this just before we started filming this podcast that I think applies. There is someone on social media that is very pro getting people screened for colon cancer.
Right.
Very important. As a primary care doctor, we talk about it. And we've set this line of 45 as the age to start. We lowered that from 50. I don't know how it is in the UK, by the way.
I'm not sure.
I'm sure it's quite
Somewhere
similar.
Yeah.
And we also throw in if your family member was diagnosed 10 years before their age of diagnosis. So if they were diagnosed at age 35, we would start screening you at age 25. Yeah. So that's our general screening philosophy. That's when we would give a colonoscopy recommendation to someone who is healthy, has no symptoms, feels great. But we would still check them for colon cancer if they fit that criteria. Yeah. Is that the perfect criteria to catch all cancers?
No.
No. Because if we try to be perfect in healthcare, what we end up doing is potentially catching some cancers, but also now getting a bunch of people hurt by the colonoscopy, because a colonoscopy, while it's safe, still has side effects. There's dangers from putting a scope inside your body, putting air, etc. Even the procedure of taking a biopsy can have some risk. And when you're doing these at scale, because that's how we judge these public health programs, we have to balance that. And sometimes we create arbitrary balances, like this 45. Does that mean if someone who's 44 might not be a good fit? They totally could be. But we set this arbitrary thing because we can't be 100% certain. And at times when people have certain symptoms, we recommend getting a colonoscopy. That is no longer a screening colonoscopy. That is now a diagnostic. Because they have a symptom that we suspect is pointing us to the fear of colon cancer, and we're getting a scan or a camera. I don't know what we would call it. Imaging. Internal imaging. And in one of the conversations that I had on this podcast, I pointed out that there are some patients that come in wanting to get a colonoscopy and they clearly don't need one. And someone saw that, who's very pro colon cancer awareness, said, how in the world would you deny someone a colonoscopy? And I think it's a very nuanced point, because it's not about denying. It's ultimately about trying to do the best thing for that patient. So now if someone comes in and says something like, my buddy just had colon cancer and I'm 28 years old and I have no family history, I have no GI symptoms, that person doesn't need a colonoscopy. And it's not because I'm withholding the colonoscopy because I want to like guard it, but it's because ultimately that risk benefit ratio is no longer in that person's best interest. So that's an example of someone who might want a colonoscopy, but clearly isn't in the good risk benefit portfolio. And I think what happens in our poor healthcare communication, in our shitty healthcare system, I don't know how much you love or hate the NHS.
I love it. But,
okay, good. I've seen both sides of people.
There are things wrong with it. Sure, it's nowhere near perfect.
We're definitely.
But I'm like pro NHS.
Pro NHS. So in our healthcare system, people come in saying, "I've lost weight without trying. I have bloody stools. I have this upset GI system," and want a colonoscopy, and then they get shut down. Either insurance doesn't cover it, the doctor belittles them and says you're fine, and then they extrapolate that.
Yeah.
And that's why I think it's like quantum.
Yeah. I can see,
that was the worst, longest analogy that I spaghettified that.
You really did. Yeah. But I appreciated it. I agree that it was a good analogy.
Okay, fair. But now that we're talking about healthcare.
Yeah.
And I think that was the worst possible segue, but it got us here.
It got us here. Yeah, exactly.
Yeah. Just like perhaps the Big Bang wasn't the most effective way to create life, but it got us here.
Yeah. That's very true.
Tell me why you loved NHS.
Well, I just think it's amazing because
for folks who are listening, the NHS is the National Health
Service
system
in the UK.
Or service.
In the UK, yeah. And basically it means that you could never make, I like to show this, you could never make Breaking Bad in the UK, He would, the whole premise of Breaking Bad, right? He gets diagnosed with cancer and he can't afford his treatment, so he starts cooking meth, right?
Yeah.
No, in the NHS, he'd get diagnosed and they go, let's get you treated. And then you leave at the end of the day and there is no bill. You give birth.
What do you guys watch
there
on
is
TV?
No bill. You need any sort of drug, that's fine. There's no, obviously you have to get prescribed it, but at the same time, like there is no charge for it. And I cannot even express to you how bizarre it is to hear some tales from people in the US as someone who lives in a country with a national health service. When you hear people being like, I had to go in for this life-saving treatment and it's bankrupted me and now their entire life is derailed or whatever it might be.
Right.
It's just something I think you grow up taking for granted that it will be there. So the idea that if it ever did disappear in the UK is absolutely horrifying to me because of I don't think we realize what we have. Yes, there are things wrong with it and yes, there are things that could be improved, but it's fantastic.
Yeah. What can be improved? What don't you like about it?
I think the waiting times for things that are elective, not necessarily elective, but like things that aren't life-threatening,
right,
are way too long. They can be, over a year to get say, like a hip replacement or something or a knee replacement, whatever it might be.
Something for quality of life.
Exactly.
Perhaps,
Yes. People can be waiting a long time for something that would massively improve their quality of life.
Right.
And that is hanging over them and that is very stressful. And I can get that. And people who can afford to go private in the UK, people can still pay for healthcare if they want, they can skip that line. So there is still a definite wealth imbalance in that healthcare side of things. But if you have a life-threatening condition or if you are going through something like a pregnancy and wanting to give birth and stuff like that, the NHS runs like clockwork for that. And it is just fantastic.
You've had some experience.
I have, yes. I have first-hand experience the past year.
What's that been like?
Horrible. But the NHS side of things, everything has been lovely. So I guess timeline-wise, just to give you an idea of how quickly I was seen in terms of the NHS. At the start of May last year, I found it was a slight dimple on my left breast, basically. And I knew that was a sign of breast cancer. And I went, I should probably go check that out. It was so slight. It was barely even there. It was in certain lights in a mirror. I was like,
unusual.
What is that?
Well, it's important that you knew what normal was for you.
True. Yeah.
That's a good starting point for people.
Yeah. And I went to my GP, the family healthcare doctor, and they sort of looked at it and went, I don't really think it is anything. Maybe keep an eye on it, or I can just refer you if you want to get it checked out for just peace of mind. And I went, yes, let's do that, please.
And refer you means refer you towards imaging or a specialist?
Yes, yeah, refer you to essentially a breast clinic to have a mammogram and an ultrasound, and if they'd seen anything, a biopsy.
Great.
So I found that start of May. I waited a week, rang my family healthcare doctor. They got me in the same day, which was the Wednesday. The next Friday, I was at the clinic getting it checked. They did an ultrasound and went, there's something there. And they took a biopsy. And then 2 weeks later.
That quickly?
Yeah.
Wow.
The same day. 2 weeks later, I found out the results. So that was all in the space of about 3.5 to 4 weeks from me finding to diagnosis. And the diagnosis was, sadly, breast cancer. It was hormone positive, which I was told at the time was the best news I could have received in terms of if you were going to have breast cancer, it was the best kind to have because they could throw everything at it if it's hormone responsive, which was, I guess, a good news, but I didn't really appreciate it for what it was at the time, because it was just like hearing those words, your entire world just comes crashing down. You know, it's one of those things where you think, what did I do? There isn't anything you did, you know, why me? You know, because random chance, you know, by all the metrics of like, you know, eating well and staying healthy and maintaining a nice weight, not nice weight, like a good weight. And then, you know, not drinking too much. Like I wasn't in any of those categories. I didn't smoke, anything like that. So you just think this is just bad luck, you know? And to have it at like the age that I was as well, I was 35, like it's very young for breast cancer. It's not unheard of, but it's very young. So it was just really bad luck, but coming to terms with that was really difficult. We found out on like the Tuesday, and then on the Friday we went on holiday. We had a vacation planned with my mum, dad, my sister, me and my fiance, and it was possibly the best thing that could have happened. Like it was already booked and we were already going, and we just went away for the week, and all of us were just like processed that information together. And we went to Austria, massively recommend it. The Alps there are amazing.
Wow.
Hiked a mountain and was like, oh, I can still hike a mountain. I'm still fine when I get to the top. I still feel like me. This doesn't define me. It doesn't label me. And it was like, I had this weird like mental clarity at the top of this mountain. Like, I'm going to be fine. Like, even if everything's not fine, like I'm still me and I can still do things despite this thing, you know? Which I think was a very good thing to have happened so soon after getting the diagnosis. So.
Yeah. When you, at that moment, were getting the diagnosis, were you processing what they were presenting to you? Or
no, it was very overwhelming, very, very overwhelming. Because they told me basically the whole treatment plan, and they were like, "It's going to be a year," and I was like, "I'm getting married in a year. I don't like this. I don't want this to be my year. You know, we need to finish this in like 6 months. You know, and I think we did finish it in 9 in the end, but like it was touch and go there for a long time. But they were basically like, we'll have to do surgery. You might need a second surgery if we don't quite get like all of it or all the margins we want. You might need chemo, and you will definitely have radiotherapy. And if your genetic test comes back for BRCA, then you might have to have a full surgery, a full I can't remember the name. Mastectomy. Thank you. And thankfully that came back negative, so I was very relieved for all of my female relatives that they weren't affected as well. But yeah, it was like processing what would chemo mean and what would a surgery mean. What would that look like? I just didn't know, and this was so run of the mill for the doctors that were speaking to me, you know. And one of my colleagues said something fun. He was like, you know, in the nicest way, you're boring to them because you're very typical case. You know, it's when you're not boring that you all of a sudden should worry. So that, again, you know, it sort of helped me wrap my head around it. And I, like, looking back, like I wouldn't have wanted them to not tell me all of the treatment plan that I had in store for me. Like I wouldn't have just wanted them to say, well, just talk about the next step. Don't think about it. Because I would have been like, no, tell me what is I need to know the plan, you know? And I'm so much better with the plan. And when I know the plan, I'm like, great. But it was so overwhelming because I just never thought about it before. And I thought I was going to be one of those people that like reads all the research papers and reads all of the stats and the things. And I just wasn't. I was like, I'm a scientist. You're a scientist. I trust you to do your thing. You just tell me what I need to do and I'll be there, you know? And I was just like, fine, whatever.
Who was the first person you called when you got the diagnosis?
Well, I was with my fiance, and then we drove home, and my mum, dad, and my sister were waiting at home. And so we told them in person there. And they were my core people.
What was that conversation like?
Hard. Yeah, everyone was just really like, what is going on? Like, you know, my parents were just like, I don't even, they'd never been through anything like this, thank God. They were just like, they had no idea how to help me through it because they hadn't been through anything like it. And, you know, they just didn't know what to do because they also didn't know anything about it either. So the questions I had, they couldn't help answer or anything like that in the way that parents want to do with their children. Sure. My sister is my little sister. So all of a sudden she's thinking, you know, I have to take care of her now. The dynamic almost shifts and stuff like that. And everybody was just shell shocked, really, I think is the way. So yeah, because it is just a the thing that just explodes your life, you know? All the things you think are important all of a sudden stop being important, and you have to put them to the side. But all the time, you know, every time someone said, you have to have this thing, you have to have this thing, I was just thinking, how's that going to impact the wedding? Because I was planning a wedding, you know? It's the only thing on the forefront of your mind when you're doing that, right? And so you're just thinking, okay, if I have to do that in 6 months, how does that then affect what I'm going to look like a year later or something like that, you know? So
it's interesting how such a potentially life-altering diagnosis, or if it was missed, how much it could have been a life-altering misdiagnosis, how much it can impact one's life, and yet it's the small things that matter. The conversations you had in that exam room, the conversations you had with your family coming back, the fact that you're thinking about your wedding. You're not thinking about, will I grow old? You're thinking about near future. You just want that next step.
Well, I had the similar thing with COVID, and I don't know if you had the similar thing, but like when they announced lockdown in the UK and they were like, you can't go anywhere. I remember vividly people being like, hang on a minute, it's my, you know, grandma's 90th birthday at the weekend.
Right.
We've got this table booked at this restaurant.
Yeah.
You know, and you're like, no, like
zoom out.
Yeah, zoom out, exactly, right? But you have this thing that you're fixated on in your brain, and it's like your brain can only focus on that one thing. So you're not thinking about the repercussions of where am I going to be in 10, 15 years, because your brain can't zoom out. It's like, I have to fixate on this one thing, and that's how I'm going to cope with this, you know?
Yeah, it's how society has been structured for so long, because so many things are happening. There's so much information being thrown at us that we're really just like, let's think about the next thing, because thinking about everything is overwhelming. And I understand that. I actually see that pattern play out a lot of times with specialists, given the fact that I am a GP. I oftentimes see specialists make plans for patients based on that same mentality of, this organ is struggling, is suffering. We need to do everything we can for this organ. And I'm like, hold on, they have a wedding in a year. Hold on, they're a person outside of this chronic kidney disease diagnosis that you've placed.
Yeah.
And that's, I feel like, the beauty of becoming a little bit more holistic in your thought process. But at the same time, probably has how I experience it, looking up at the night sky. To me, when it's so open, it's overwhelming. So there's like levels to that of how you experience these conditions.
Yeah, exactly. But I felt like I had to advocate for myself a little bit, you know, in that
a lot of it.
But like, you know, for example, after surgery, the next step was maybe you'll need chemo. They did some diagnostic tests. I don't know whether you're familiar with like oncotyping, things like this, the pathology, which says like how at risk are you of recurrence. And mine was right on the borderline, which was really annoying because I could have avoided chemo, but I didn't in the end. And I was like, oh. So I did have to have chemo, and they were like, okay, so like this is if in your pathology case, this is what we would recommend. And it was, you know, a course of chemo that was a dose every 3 weeks. So it was going to take like 5 months. And I went, no, I want to do it quicker than that. And they went, well, you can try doing it what we call dose dense, which is where you have a dose every 2 weeks, but you have to have injections to boost your white blood cell counts. And it's likely that you won't make it to the end of the regimen still doing it every 2 weeks, because your body will have just been blasted basically, and will need time to recover. And basically if you do it every 3 weeks, basically you have a week where you feel awful, a week where you start to feel better, and then a week almost of normalcy. And by doing it dose dense, you kind of get rid of the week of normalcy.
Right.
But I was just like, I want to feel better. If I'm going to do this thing, I want to get it over with as quick as possible.
I'll feel worse for shorter than not as bad for longer.
Exactly. Yeah. And so it meant I did it in like 3 months rather than 5. And somehow I managed to stay on the dose dense all the way through. And my last chemo dose was like the Friday before Christmas.
Wow.
And so I managed to like finish, and like, you know, it was like done.
How'd you celebrate that?
I ate so much like food that I couldn't eat during chemo.
Okay. What foods?
Like cheese. Like you're not allowed to eat like,
fan?
oh God, yeah like cheese and wine. And I didn't want any alcohol during chemo at all, because chemo basically, my first dose was like horrific. It was like the first 3 doses were this one drug and the last 4 were a different drug. The first one, it was just like the worst hangover of your life, combined with flu, combined with COVID, like combined with like old age is what it felt like. It just felt like I'd been run over with like a truck basically. And I just had that sort of feeling of like, you know, when you're slightly drunk and you don't want someone to know that you're drunk. Like if you're on like a FaceTime call with them and you're like, must focus.
Yeah.
Like I was on a FaceTime call with mom and dad and I was
don't
like,
fall asleep while driving.
Yeah, I can't let them know that I'm like feeling this crap. So I was like, focus. And then like they'd be like, Becky, you okay? And I'd like catch myself and I'd like fallen almost like asleep and like rested and like sprung back awake and like, yeah, I'm fine. I just couldn't focus like on that first drug. And I thought it would be like when you're ill and you wake up and you feel better the next day. And yeah, I just woke up and I didn't. And it just was like that for like 4 or 5 days. And I was like, am I going to be like this for like 3 months? And I just couldn't see the light at the end of the tunnel yet. And finally I woke up on like the 6th day after that first dose and felt semi-human. Like I could walk downstairs to make myself breakfast. And I was like, wow, this is an achievement. And all I wanted to do was like go on a walk. That was all I wanted to do. And I was like, I can't leave the house and go on a walk. I can't do that. Now, every time I go out on a walk, I'm like,
you appreciate
this is
it.
amazing, you know? Like it's amazing just to be even walking around and not just like in bed. Like I couldn't even read a book. I couldn't focus to read. And so I like just listened to audiobooks the whole time, just lying in bed with my eyes closed and was just so grateful. Any moment I could just get up and walk around.
Were you scared that that was going to be your permanent existence?
Yeah. I had like a week where I was like, what is this? Is this going to be what the next 3 months looks like? And it was just, I just don't know how people do it. And like, I remember thinking at the time, like I've always heard and like maybe watching like medical dramas and stuff, right? Where people are like, no, I don't want the chemo. And they decide they don't want it, you know, or they've had it before and they decide they don't want it again kind of thing. And I never understood that mindset. I was like, I'd be the kind of person that, you know, you throw everything at it. And then going through that, I was like, oh, I see now why people don't.
Yeah.
Why people decide that. Just because it was a lot. And I was cold capping throughout the whole thing as well, which is an absolute medical miracle.
Tell me more.
So they put this almost like skull cap on your head.
To decrease the likelihood of
losing
hair
your
loss.
Yeah. So it like pumps cold water through it so that you're essentially
decreasing circulation.
Yes.
Of the
it takes
agent.
your blood out of your scalp. So the chemo drug doesn't reach your hair. And oh my God, it's incredible. Because I kept my hair. Or at least the majority, like 80% of it. Like I lost my sideburns, like because the cap didn't come that far down, and they're growing back now, and I'm like, yay! And
You're like, I never missed my sideburns this much.
I'm like, look at them grow. It's very, very fun to watch them come back. But yeah, so I lost like 20% maybe of my hair. It didn't stop like shedding, but it kept the majority. So like looking at me now, I don't think you would realize that I like, lost it fine. Which was part of the like psychology again of not feeling like a cancer patient. You know, I think as soon as you like even with surgery and radiotherapy, I never felt like a cancer patient. Like chemo, when I was on the ward, I did, but like otherwise at home, I didn't feel like I identified as that in a way, even though I was.
How come?
It felt like something it wasn't happening to me almost. It was like something that I was just having. Like? Yeah, a little bit. It was just something that I had to just tick a box. And I think because when the surgery I had was under a general anesthetic, I woke up, walked out of the hospital an hour and a half later. Like I had no issues at all. Wasn't in a lot of pain. Was absolutely fine. So I don't know whether I just lucked out in that respect, that I didn't have a bad reaction to the anesthetic, that it was just in a place that meant that the surgery was easy, that it wasn't painful, things like that. I did have to have a second surgery because they didn't quite hit margins around the tumor. Fine. But again, walked out an hour and a half later and then just was at home recovering in the way that like if I'd twisted an ankle you're just at home recovering. So it felt very removed from cancer patient, and I think when we think cancer patient, we think someone who's going through chemo, someone who's lost their hair. And so holding on to my hair meant that I didn't feel like I identified in that way. So I didn't have that sort of psychological burden to get over.
Were there any members of the healthcare team that stand out in your mind as people who helped you through the journey? Yeah.
I had what they call breast care nurse. So she was like my point of contact the entire time. She's called Lainey. She was lovely. Hi, Lainey. If you're listening, I don't know. But essentially like anytime I had a question about the process or I had something that I didn't think was right, she was the person that I would ring. And she would ring occasionally just to check in and go, how are you doing? And she was the person that was almost zooming out for me as well, right. Being like, how's the wedding planning going? Are you okay? That kind of thing. Or this is what this means if you have problems. And so having that point of contact that was trained almost in sort of, here's how to talk to people who are going through this as well was so, so useful, but knew the big picture, but knew your scenario, she was just amazing having that there as like a fallback in a way. Because with the doctors, you know they're on it, but you have like half an hour of their time for the appointments, and you don't. I'm one of those people that's like, I don't want to mess up whatever you're doing, so I'm just gonna, I'm going through airport security, and I'm like, I want the gold star, I want to be like the perfect passenger for your day, and I think
you're like, I'm a pupil.
Exactly, right? I'm like, you have your things that you have to do. I am here. Do the things you need to do. And then I'll ask my questions and I will go, and like, I don't want to take up too much time. So having like the nurse there where it was literally like nothing is too much was great.
Yeah. It's interesting to hear what people remember from their journey. And I'm curious, given how much misinformation there exists for the cancer treatment world on social media, was there ever a time where perhaps you read something or you just had an internal feeling where you thought you made the wrong choice?
Not necessarily the wrong choice, but I think I definitely got the wrong information from online. So when I was freaking out about needing chemo and not wanting chemo, and then I found out I did, I'd sort of seen that, typically in my case, people would only have given me a short like regimen of chemo, which was actually the last 4 doses that I did have. They wouldn't have given someone of my age the 3 stronger doses I had at the beginning of a different drug.
Okay.
And like that would have been like the typical medical sort of pipeline that you would have gone down. And so I sort of like was like, okay, it's going to be fine. And then when I got into the appointment where they said, oh, actually, no, you're going to be on this, it then hit me harder almost because I'd sort of thought that I already knew.
For that.
Yeah, I'd read something online that was probably, maybe some doctors do that, but like I thought that was going to be my path. So I thought I knew the plan, and then the plan was different and it was going to be worse.
Did it help you to be able to ask that question, that why your plan is different?
It did. Yeah. And it was nicely explained to me why in my specific case that it was going to be that way.
Were your doctors or the people that you were asking that question to accepting of the fact that you were asking those questions?
Yeah, they were.
There's a lot of doctors that are like, your Google search doesn't replace my degree. And I'm like, don't do that.
No, and it was very helpful that I'd done the searches as well because my partner hadn't, and he, was struggling to keep up with the conversation because he didn't know the terminology necessarily. Listen, he was like, I'm going to be like the notes taker in every appointment, so you don't have to worry about remembering everything.
That's
so
important.
He was great for that. And I think it was important that I'd done that, but it was not from a psychological perspective of knowing what was coming, if that makes sense.
Yeah.
But yeah, it was funny in my case because I had people asking me like, oh, and are you all clear now? And I was like, well, I had no spread, thankfully. So really it was just a case of, in case it has spread, we're going to give you chemo, but we don't know if it has or not, like micro metastases and like in the blood.
Quantum
random. Exactly. And this is the thing. It was like one of those things where we don't know in your specific case, but on a population wide level, we know that if we give you chemo, you've got better chances.
Your rate of recurrence is lower. Yeah.
Exactly. And so it was one of those things where it was just like, okay, yeah, if we want to throw everything at
you're
this.
younger, so you have more years to live. Like if you're older, perhaps that was unnecessary.
Exactly.
I'm sure that's like
that was basically the main thing was like we're protecting more years of life.
Conversation, and that's how a lot of times decisions are made in healthcare. Whereas to an average person, it's like no, just do the best thing for that. But like that's different. Years of life, what's important to them? Do they have a wedding coming up? Like these things are not medical per se, but they impact medical choice and the individualistic part of healthcare. Because we have a lot of great evidence on a population level. But how that then applies to you as Becky coming in and saying, I have this going on, this is what's important to me, this is how I want to live my life, that should change the plan.
Yeah.
And if it doesn't, perhaps the doctor is not doing right by you.
Well, yeah, exactly. But I think that was good that they were like, okay, you can do the dose dense. If you want to do it quick, then we'll do that. I tried to speed up radiotherapy as well, because usually it takes like 3 weeks of like a lower radiotherapy dose each time. But they were like, oh, we're doing a trial where it only take a week, where it's like a higher dose each day. And I was like, put me on the trial. But I got on the control and I was like, damn, science controls.
And you knew, or you found out afterwards?
I found out afterwards.
Okay.
Yeah. So I was like, fine. I'll take 3 weeks then. So it took 3 weeks, but fine.
But that's a huge benefit that people don't talk about, or at least don't realize of NHS, because you have all the data from the national service. You can actually do good research. Whereas ours is so fractional and fractured that it's like, I have a little bit of data from here, maybe a little bit from here. This system doesn't talk to that system. So when I try and make them speak to each other, it's a disaster. That's one of the big advantages of having a nationalized
Yeah.
healthcare system.
I have a friend for my PhD actually on talking about where do astrophysicists go after they've done their degrees. She actually now works at like the UCLA, or if not the UCLA, so just like UC, the University of California, like medical group, doing a lot of the sort of like the AI sort of like prediction, I think, side of the medical, I don't even know. I think it's AI and medical stuff. Diagnosis, that's the word. Yeah. Oh, brain fog from chemo still. Diagnosis was the word. Yeah. And the research side of things. In terms of just like the big data, because the UC group has sort of a significant data set, I guess, in a similar way to the NHS. Yeah.
No, it's really interesting how certain groups, Kaiser is a big one in the US, but ones that either cover certain areas, demographics, perhaps work, insurers sometimes have certain groups that get taken care of thousands of patients by one system. That's really popular to study those groups. I wanted to ask, because there is so much misinformation that I mentioned earlier about cancer, there are people who are like, skip the treatment that your doctor is giving you and just live healthy, live naturally. What do you want to say to those people?
I want to say that you're gambling, right? And yeah, your gamble might pay off, but the gamble might not pay off. And the thing is, you only hear from the people that the gamble pays off for.
Yeah, that survivorship bias is
survivor
real.
bias, exactly.
It's huge on social media because it takes one person to survive.
Yeah.
And that content gets selected by the algorithm because it's so valuable to the ear that now that's the example.
Yeah. Exactly.
Whereas the 99 other people who did not survive, no one hears from.
Exactly. And that's the thing. And I was so glad, I think, because so much of medicine's like not diagnosis, but like decision on how to treat a patient, right? And what best to do for them is based on that population statistics of what's been seen before in terms of like the risk versus the benefits. And like, you know, in this percentage of people, this thing happened versus this percentage of people. Like I got that from the start because of my background in science. Right. And I think that the healthcare team could see that they didn't have that burden to cross, like when they were explaining what was going to happen with me, which was, I guess, helpful.
It's definitely a big barrier.
Yeah.
When the level of health literacy is low in a patient.
Yeah.
Because I might not even begin to start talking about the diagnosis or let alone the treatment until we get to an understanding of what could be happening, what we can do, what options we have for checking for certain conditions, and me understanding what they know versus what they don't know and what they're afraid of.
Yeah.
And having a patient tell me what they think is going on, even though when they're not scientists or scientific, is so valuable because it creates a way for us to communicate in a way where then that information can land, not in a manipulative way where I can get them to do what I want, but so they could choose what's actually best for them. Yeah. That's what a good doctor should help you do. It should help you make the best decision for you, not to push you one way or the other. A lot of times the recommendation we're making is usually what's in your best interest, but there are instances where it's absolutely not, and that's okay.
Yeah, yeah.
And I think in the US, I know we've talked about like the Jubilee and these debates and things. In the US healthcare system right now, the people who are in charge, where I feel like they're making their worst mistakes, is when they go in front of our Congress and they get asked questions before they take on their positions. They'll ask them a question about a vaccine and they'll say, well, yeah, the vaccine works, et cetera, et cetera. Then they'll say, well, do you think it causes autism? And we know from the scientific research it does not.
Yeah.
But they avoid the question and start talking about individual health. Well, everyone should have a choice as to whether or not they take.
That's
individual. That's the conversation you can have with an individual patient. But you can zoom out and say, on average, this very healthy average, these things are safe. They help people more than they hurt. They do not cause autism. But then what you say in an exam room can be different because it might be different for that patient.
Exactly. Yeah.
But the difference and the nuance between the public health and individual health thing gets lost so often.
But maybe that's because those medical professionals are used to just talking to the individual in that healthcare room. They're not used to talking to on a population level to like in that context of being in Congress, right? So,
I think in those scenarios, if that's happening, that's by definition them being not fit for the job.
Yeah, right. That's what I was going to say next.
Their job requires them to do.
Yeah, exactly.
So like that's totally okay. Maybe then be a physician on an individual level because in healthcare you want to have good micro care.
Yeah,
micro care, what happened to you, but at the same time you want good macro care, decisions of what research to fund versus not. What avenues make sense? What avenues can we take a moonshot at and potentially find a cure, even though it likely won't find a cure? Like looking for the furthest black holes or whatever, exoskeleton planets.
Exoplanets. Exoskeleton planets. Whatever that is.
Sorry, I'm creating terms. Spaghettiing, different materials. So it's a messy system.
It is a messy system.
Do you have any curiosities about healthcare that you've been curious about? That I could perhaps answer?
Oh, I wonder.
Is there anything that has come across your feed, perhaps?
I'm trying to think. You put me on the spot.
No, that's the thing. It's like no pressure.
Yeah.
But if there's anything that you're like, oh, you know what? I was reading about this trend thing that people were doing.
Yeah. The bizarre thing is I think of myself as so like not up on medical stuff, but I watch Grey's. So,
well, that's it. That means you're an expert now.
I could do surgery up to 20 seasons, whatever it is. But no. I think I wonder how you feel about the sort of stuff that's come out of like the fertility space of like, not gene editing necessarily, but like like how you feel about that kind of stuff. Because they can do so much good, but can also be ethically murky at times, I guess.
I don't have a revolutionary stance on this. Mine is very much in line with the general scientific consensus of unless you're doing it for a condition that is otherwise fatal, you're gambling with the ethics of humanity, which is not original.
But no.
It's a stance.
It's the stuff that always fascinates me, though.
Because I've seen people in other countries start messing with genes to potentially find a cure for HIV. And I'm like, well, hold on a second. Risk benefit. We have treatments for HIV that people live now, especially if you diagnose it early, the same lifespan with antivirals. So do we need to start messing with people's genetics for that? So I think there's like, and also I try and zoom out even more. Why say here, what happens in the US, doesn't mean that it's what's going to happen in another country. They have their own rules and their own cultures and their own beliefs of how they're going to proceed with it. So like the idea that one scientist or one doctor somewhere has some belief, it's fairly limited. Which is why I think the power of consensus is so valuable. And people undervalue it these days. Do you have friends that are anti-science in your life or loved ones?
I don't think so. No.
That's amazing. You're really lucky. No, like I can't turn a corner without having someone.
Oh, wow.
Either in my personal life or professional even, where they're like, oh, but that's bullshit. I'm like, well, what?
Yeah, I haven't come across it.
So what happens to you if you're sitting, you guys don't, like, what's your biggest holiday?
Christmas.
Is it Christmas?
Yeah, I guess so. Yeah, Christmas.
Like, that's your national holiday?
Yeah.
Wow.
No, it's like most people will take a week off for Christmas.
For Christmas. Okay, so you're sitting at Christmas dinner and someone looks at you and he goes, come on, it's flat. What do you do? What?
Like, what are they paying you to say?
Yeah.
No.
You NASA shill or whatever. What's the opposite of a farmer shill for?
I think I'd probably be too many glasses of wine down to care, to be honest, on Christmas Day. But yeah, I think it's hard, especially if it's a loved one. Like you'd be like you wouldn't know where to start.
You'd be shocked.
Yeah.
Wow, you live a really pure life. No, I'm saying, like, it's really impressive.
I'm realizing this now.
That you have such great people around you that no one is questioning science.
Yeah, I feel
is that the temperature in the UK right now? Is that the climate?
I was about to say, is this maybe like a
US
UK
problem?
education system kind of thing? But I don't know, maybe. I think so. I don't think there's many people that question science as much.
I cannot believe that. I'm so jealous. I've never been more jealous.
I think we did have a lot, to be fair, during like COVID and stuff. People were questioning but like from where's the evidence to back this up that you have that like lockdowns help and all this kind of stuff and everything.
I mean,
and
those
the
are
like that fine.
Government rules versus science rules.
Yeah, but in terms of like, I mean, there has been, to be fair, like a drop in vaccination uptake. I don't think it's been as extreme as in the US, but I think that's because of like the globalization of social media.
Yeah,
necessarily, it's sort of like infiltrating and coming over necessarily.
Yeah,
a little bit. But I don't. I personally haven't experienced that kind of like science denialism.
I bless you. Continued experience with that.
I will stay in my little happy cocoon if I can.
I promise if you go downstairs here in Times Square,
I'll find someone. Yeah,
you won't find someone.
I'll find a few.
It'll be a lot. So
yeah,
clearly we need to make some changes very rapidly. Okay, so if we're now looking into a telescope that looks into the future, I just created this telescope.
Sure. Yeah.
And we're looking 10 years from now. Where's Becky?
Oh, where am I? I hope I have a permanent job at the university, because at the minute I am in that fun stage of academia where I'm between PhD and professorship. So I know in the US professorship is just anybody who teaches, but so it's like tenure, right? I don't have tenure. Yeah, is the way that you would say it in the US. And so I'm on
But you have a PhD.
I have a PhD, and I'm
But you're waiting for
hired by the
tenure.
university, and I am on like 3 or like 5 year contracts at a time.
Got it.
Where it's like, here's your research to be funded for 5 years. Great. So I don't have that like job security.
Stability, yeah.
And then I do YouTube stuff that doesn't have job security and stability.
That's the least
So right. So you have like both of these jobs that don't do it. So I guess I hope that I am in a position where I have like a tenured job so that I can sort of relax a little bit into the research side of things. And there's not that like constant feeling of being on a treadmill of like go. Otherwise you won't have a job by the end of it.
Fair.
With like a really nice research group, that's like a lovely, like, very happy, like enthusiastic little group of like, we just love what we do. And I have loads of like PhD students who are my little minions, and they go out and do fun things, and they come back to me and we have fun conversations about science. And then I still get to share that with people. I don't know if in 10 years time that's going to be in the same format on YouTube or, conversations like this with podcasts and stuff like that. Because like the online space is very different to where it was 10 years ago.
Yeah.
But I hope it's still.
Do you watch? Are you a consumer of
I
social
do.
media?
Yeah,
What
I
you
do. I mostly watch YouTube. So I watch a lot of travel content. I love travel content.
Okay.
And a lot of like sort of like outdoor and like hiking content and stuff like
cool.
that.
Okay.
But then I also really enjoy a lot of like STEM content as well that's outside of my field. So STEM, like science, technology, engineering, maths, that kind of thing.
Thanks.
So actually,
I really made myself sound dumb at the beginning of this conversation. She's like, I got to define STEM for this guy.
It was just because I realized there are people listening who might not know STEM.
Fair. Okay, thank you. Thank you for rescuing
I thought it was a UK US thing then. I was like, is that another thing? Yeah. So I do watch a lot of that kind of content too in like the areas. Like I still have my love of marine biology, and I watch a lot of that content and
Dolphins.
stuff like that.
Is dolphin still the favorite animal?
Although I love the lobster guy who catches the lobster off the back of his ship in Maine. And he's like, we got an egger. See, that's a really niche random bit of YouTube that I'm on. Yeah, it's this guy who like catches lobsters, and he's like, I have to, the females that reproduce, he's like, he marks them, gives them a fish and throws them back in the water. Wow. And I just love the comments that like, can you imagine if like an alien abducted you, gave you a stack and then threw you back down?
Oh my God.
Like it's so fun.
Okay, so
I do watch a lot of that kind of stuff.
Do you like Neil deGrasse Tyson?
So Neil's fun because he was a practicing astrophysicist at one point, and now he just solely does science communication and stuff. And he's kind of like our Brian Cox,
he's no longer an astrophysicist.
Not practicing, right? It was like a weird thing to say, I guess.
Because like
he is an astrophysicist.
If you're a doctor, whether or not your medical license is active.
Really? Okay. Well, you mean you have the title? Yeah. Of course. Yeah. He's Dr. Neil deGrasse Tyson technically because he had his PhD, right? But it's interesting.
So he's a retired astrophysicist in your mind.
A little bit. Yeah. Like he's done research, he's done science, but now he's solely focused on the science communication. So I was about to say he's kind of like our Brian Cox. If you know Brian Cox, he's a professor of particle physics at the University of Manchester.
Mike Cox, who destroyed Pluto, right? That's his name?
No, it was Mike Brown.
Oh, Mike
Brown. Pluto killed. But yeah, he's a professor at Manchester, and then he does a lot of like, BBC big documentaries, that kind of thing, so they're very similar, but Brian Cox is still actually
so you like the content
and doing research. Yeah, he reaches such a large audience and everything, so yeah, I mean, it's great.
Yeah. All right, so 10 years, more black holes.
I hope so. Yeah.
Or less black holes.
More. Let's go more. Yeah, let's go more black holes.
More, larger.
Yeah, because like population statistics, right? You want like the biggest thing you can get at so you understand the stats better of
Would
what's
you ever
going
go
on.
to space?
No. So people always ask me this. And I think there's the two parts of my personality that war. The part of me that is like always get a window seat on an airplane. Always, always, always.
For survival?
No, for the view.
Oh, entertainment.
Yeah,
Okay.
yeah. You can see the aurora from a plane, if you sit on like
I don't like looking outside. I'm afraid of things.
No. Oh. Yeah, I'm like, right, I've got a night flight back from the States, so I've got to be on the left-hand side of the plane, so I'm looking north, so I might see the aurora.
Wow.
Yeah, like I'm like that level of planning.
Strategist. But you won't go into space.
But I want, because then the other part of me that's like, I like my feet on the ground, I'll look through the telescope, I'll look at space. I can't do any science from space. So
Well, yeah, you can. Space
I
station.
can't do my science
Why
from
not?
space. Well,
They don't have telescopes
I could
up there?
physically, I guess, just take my laptop and sit on the ISS and do my science. But like, I'm not going to go to space to do like an experiment or anything like that. So I don't really see the point of me going to space. Like to experience 0G, maybe I'd just do the vomit comet. The plane that flies in the hyperbolic orbit, so the hyperbolic drop and rise again, so you feel it, right? But I don't think I would go to space. Maybe if space travel became as blasé as like air travel has now.
Oh.
Right.
Okay.
Maybe.
Are
I
you
would go to space.
anti-commercial space travel? Like, do you like that people are going to space?
I'm a little bit conflicted.
Yeah. And does it
that's just
count
me.
what they're doing as space in your eyes?
The thing that like, does it count if they've gone to space? Because some of them don't cross what's called the Kármán line, which is like this arbitrary threshold that somebody drew to be like, below this is aircraft, above this is spacecraft, right? It's not based on any scientific definition. It was just they needed some terminology when the space race was going on. They were like, right, okay, this is aircraft, this is spacecraft. But there's no like line where it's like that's the actual edge of the atmosphere, because the atmosphere just slowly just gets less dense and less dense and less dense as you go.
So where's your line?
Where's
the Becky line?
I don't know, the edge of the solar system, the heliopause. I don't know.
So do they cross this line for you?
No.
So they're not in space.
I mean, like, I think if you're going to the moon, like, I mean, they are in space because they're experiencing if you're experiencing like 0G,
okay.
If you're orbiting the Earth, you're high enough to be able to orbit the Earth, and fine.
Okay, so you're conflicted on.
I think I'm conflicted on the benefit, and it's this like, it's not really risk benefit like in medicine, but it's very much like, is there a point to us doing this? But also, would it help science in the long run? So you're
thinking about it practically.
Yeah. So there is a benefit to commercial space companies coming in and making it cheaper and better and more efficient, and recycling rockets and things like this, so that when we want to launch missions to the other planets, or we want to launch new telescopes, that is cheaper and more efficient and easier to do, right? That's great, because if it makes more science possible, then I'm all for it.
Sure.
What I worry about is, this idea of that then, okay, well, what if a company can decide we're just going to go to Mars and we're just going to send humans to Mars? And it's like, well, hang on, because what if we want to answer this science question of if there's life on Mars, or was there life on Mars? And now we can't because some random space company has sent humans to Mars to do this. Same with the moon as well. Like, there's a really interesting sort of like legal discussion about who owns space. So for example, like the Apollo sites where they landed on the moon, they're like a historically important, culturally important
we planted
site.
the flag. That's official.
Okay, right. But then
that's like Sims.
what's to stop?
Like we put the flag.
Ours, right?
Yeah.
But like what's, those footprints from those first astronauts on the moon are still on the moon, because there's no weather on the moon. There's no wind, nothing to blow it away unless an asteroid came down and struck it. They're still there. What's to stop future generations who go to the moon just trampling all over that? Nothing at the moment, right?
So you're saying we need some rules, space rules.
Well, yeah, like space law.
What would be your first space law?
I don't even know. If it's going to fall to Earth, stop it before it does.
Okay, I like it.
Because we've had that a few times. And,
we got the Armageddon guys, the space cowboys. We have them all.
Yeah. Do you actually, probably people don't remember when a space station fell to Earth back in like the 70s or 80s.
Oh, no, I didn't even know that happened.
It happened
before my time.
Well, mine too. But like it happened, and it crash landed in like the outback of Australia, I think, and stuff. And if it had crash landed, they had no control over whether it crash landed, but it could have crash landed on it. It's a whole issue, especially a lot of the Chinese space
Are there
program.
a million like satellites just floating that are like garbage up there? Or
Yeah,
something
space
like
junk's a huge problem. But again, there's also historically,
like littering.
culturally
How about
important.
that? Let's
No space
rule number
littering.
one.
Yeah.
No space littering.
Yeah. But like there's a huge amount up there that could be culturally significant and important. Like there's still bits of space junk up there from space junk, meaning it doesn't function anymore, right? I mean, functioning satellites aren't junk, but stuff that's no longer communicating with Earth, right? Not functioning, space junk. But some of that is from like the space race. Like there is like, not quite Sputnik isn't up there, but like the follow-up to Sputnik is kind of up there. Should we bring that back down to Earth and put it in a museum because it's a culturally important piece of like humanity's story? But then its value is in being the
Up
oldest
there.
piece of space junk.
Yeah.
So should we leave it up there so it is the oldest piece of space junk, you know? And like it's the same with like the Apollo sites. Like do you protect those for future generations? Do you not? Like if it turns out there is some mineral on the moon that is wildly valuable and only one commercial space company can access that, then how does that play out as well in terms of like the economy and everything?
Wow, I didn't even think about this.
So there's a huge issue with commercialization and this sort of access to space as well. Like if everyone is able to put satellites up and then we do just end up with a load of space junk and the Earth's orbit becomes so like the Earth's orbit, but the space around Earth where satellites orbit becomes so congested that maybe you can't get missions out to, you know, explore other planets. I don't know. We probably won't get that dense, but also like, could it take away people's night sky? Like we've had this issue with Starlink, the internet.
Yeah.
That's, you know, a great idea, provide internet for wherever you are in the world. But at the same time, you need this like constellation of satellites, this big grid and this big network of them that if they have their way, there's going to be tens of thousands of them up there, like 5 times as many satellites as we currently have up there now, but then like 10 times in the future, you know? And so you can see satellites moving across the sky, even in cities. I've seen them before if I've looked up because they can be quite bright just after sunset and things like this. And so if you have all these satellites just streaking across the sky in random directions all the time, reflecting a tiny bit of the sun's light, you then lose like a perfect night sky that, you know, has been kind of like a right that humans have had almost without knowing it for thousands of years, right? That before we built cities was something that everybody experienced, was a pure dark sky. And there are places in the world we can still access this, you know, national parks, very wild places, things like that, and like protected dark sky sites because they're away from light pollution of cities. But if all of a sudden you take that light pollution and actually add it to the sky with satellites,
it doesn't matter.
It doesn't matter. It doesn't matter where you are in the world, even if you're in the like remotest, furthest place you can get from any sort of human civilization, you know, a few, 80 miles above your head, you'll still have human civilization, and it will rob you of this like basic right you've had for thousands of years without knowing it. So this is why I think commercialization has its benefits, but also things that we really have to think very hard about.
Has there ever been a baby born in space?
Not that I'm aware of.
That'd be fun. I want
or
to be the
conceived.
I want to be the first baby born in space.
Okay, I think that ship may have sailed for you. But yeah.
Last question, and this may get really hard, so brace yourself.
Okay.
Do you think it's bad that there's a chance NASA loses funding?
Yes, hugely.
Okay. So now you have an opportunity to look at this said camera and send a message to President Trump and tell him why NASA is important.
NASA, okay. The thing is, NASA has had its budget cut for science, specifically like astro. I'm going to explain context first, because what they've done is they've cut it, but they've moved budget around. So they've moved budget from the astrophysics, the science side of things, and put it in the space exploration side of things in order to send humans to Mars in the future and to the moon and things like this. So I guess it's whether you think, what should NASA be doing? I think they're trying to get back to what it was in the 60s when it really was just like we want to go to the moon and we want to be humans exploring space kind of NASA. And NASA has evolved to become so much more than that ever since. And so now a lot of what NASA does is more of like the Hubble Space Telescope, the James Webb Space Telescope, missions in space, telescopes, exploring, learning, that kind of side of things. One of the things that NASA's budget did have cut, though, was all of its science communication budget, pretty much, was in the proposed budget for NASA. Wow. So I guess I can't control necessarily what they want to spend their money on, but I can necessarily say something about why it is important that we communicate science.
Please, I'm going to send this to him.
Really?
Yeah.
Okay.
Personally.
Okay. It is so incredibly important that we communicate properly what we are doing when it comes to space exploration and the science that we learn from space. Part of the benefit of the Apollo programs back in the 60s and 70s was the fact that it inspired so many people into science PhDs, engineering PhDs, that then had a massive benefit to not just the economy, but also to just the collective knowledge of the world, but also the US as well. So if you want a similar like benefit from, say, the Artemis missions or any from any future Martian missions, then you are going to need to communicate properly what you are doing. And you can only do that with proper science communication, with people who are trained on how to actually translate these very complex topics and the jargon that we use when we literally are quite, using a different language when we speak scientist to scientist and colleague to colleague, and translate that for the public themselves. If you want to see that direct benefit and you want other people to agree why it's important that this continues to be funded as well.
I'm sold. Whatever budget approval you need, you got from me.
But the UK budget's being cut as well.
Oh,
we
no.
were told to it's going to be probably 30%, but it could be 60%.
Wow.
In astronomy alone, at least, because basically the way that it's structured is that we also have to share budget with like all the facilities. So like because energy costs are going up, we're now losing out on science funding, which is absolutely ridiculous. And something that we're all so frustrated about and trying to rectify and get government to sort out as well. And it's just bizarre that like we've had this massive resurgence in interest in space with, I think, people growing up with the Hubble Space Telescope and now with the James Webb Space Telescope just revealing so many new things as well, that now we're going into an era where they're going to start cutting that funding.
Feels backwards.
It does feel backward. Yeah.
All right. Well, thank you so much for your time.
Thank
I
you.
hope you had fun.
I did.
Chatting with a simpleton like me, but I learned a lot. So thank you for that.
Oh, the simpleton. We're both like super niche knowledge sets, right? I know nothing about
You know
medicine.
a lot about medicine.
I think
That's
I know
untrue.
much as like an average like human being should know about medicine and like bodies in general.
No.
So
More. Well, thank you. I hope you had fun.
I did have fun.
Awesome.
Yeah. Thanks, Mike. I hope you had fun.
Speaking of space, I've never been, but I have been in an F-16 pulling 9.3 Gs. Click here to check that out. And as always, stay happy and healthy.